Okay, perfect. So one of the things I had promised yesterday was we'll I'll go through the nested logic. So I had to run some estimates separately. So I'll go through that for the first 5-10 minutes, and then we'll spend some time on the transport economics piece again. Like go back and do some additional concepts around economic assessment. All right, and this time from a logistics perspective. So let me start. All right. So let me see if I can share my screen. You should be able to. All right. So if you remember from yesterday's discussion, I'll just drop. I shared the entire data, right? Like this was the data which we had discussed and I shared with you yesterday. It had all this information about the households and the individuals who are making choice on the left side, and then more mode specific information on the right? And we did an MNL and we got results. When I'm talking about MNL, it is multinomial logic model. Correct. So one of the fundamental assumptions about multinomial logic model is that that each of the um, factors are independent and identically distributed. But one of the things which we do know when we did the red bus blue bus problem was that it matters if they have if uh, two modes are highly correlated and can be seen together as one option, then you need to be able to appropriately correlate them into something called a nested logic model. So one of the things we identified yesterday was that walking and bike would be active transport, bus and train is public transport, ride hail and car, right? Car has a ASC of 0, the attribute specific constant as 0, was coming out to be car. So basically you're going to have three options, basically three nests, and within each nest there are options. So how does a nested logic model work, right? So we did a little bit of the framework, but I wanted to go through a little bit of the maths behind it. So let's go back to, where was that? Yeah. I didn't do nested here, not included nested in this part. One second, just give me a moment. So it's not a lot of slides. Trying to look at not this one. I think, yeah, this one. So when we did that, sorry, please 1 second. Just getting, just give me 1 second. Sorry, it's an urgent call. Sincere apologies. It was just an emergency that had happened, so all taken care of. So I'll just go back to my slides here. So when we were doing this, if you remember, the way we had set this up was that you have a first choice between a passenger car and transit, and then within a passenger car you have a utility of driving alone or a shared, right? So the probability of taking driving alone is the probability of choosing a passenger car multiplied by the probability of choosing driving alone given it's a passenger car. So it's basically a Bayesian probability, right? So how do we represent this in a mathematical nested logic perspective? So the way it is, this thing is the lower level. You remember the lower level, which is basically each of the modes is a given A. So given that we are taking a car, so which is mode M. So let's say given we are taking transit, what is the probability of taking a bus? So that is within the transit, what are the different options? So this will be exponent of the utility of the transit plus the bus plus the train, and you'd get this. Now within that nested probability, which is on the top level, the probability of taking that mode is what the way you do that is by adding this log likelihood. So you take the sum of the exponents and put that on top. And you have these parameters which are called lambdas, right? Lambdas, it is telling you how much is people are preferring each of the different type of, so in some sense, it's an attribute specific preference, the lambda and lambda k. Am I making sense so far, or it is actually a 3-hour lecture on just on nested logit models, but I'm just giving you a sense of the key concepts. The key concept is you have a nested logit model, which is this part, this lower nest driving alone. And when you come up, when you look at UPC is nothing but exponent of lambda times sum of this, log of sum of this, right? So that's what you're trying to do. Let's go back here. Log of sum of this. So these are also called the log likelihoods. So when we estimate this, we get this result. All right. So what you will notice is that I have an attribute specific constant for ride hail and for bus, but I don't have it for others. All right. And the other thing to remember, because you've got the lambdas playing out now. If I look at IVTT, the coefficient of the in-vehicle travel time, and that's minus 1.42398. What did we get here? Minus 0.0361. So your coefficients actually change. And if I look at this, the cost is minus 0.1735, and this is minus 1.3007. So the value of time now here is IVTT by cost. So if I do 1.3 divided by 1.4, it is close to 1, as opposed to here, which was more like 0.17 divided by 0.03, it was close to 4. So if you don't do a nested logit model appropriately, you might get very different values of time. So you were getting $4 a minute, while here you're getting $1 a minute. And these lambdas are what we talked about, right? Like the lambdas associated to so these are the lambdas. So for car, for transit, for a car, it's 1. For active transport, it is 0.44. Are you getting a little bit of a sense? It's actually a 3-hour lecture, but I just wanted to show you that when you run the model using maximum like MNL, you end up with different results.
Okay.
Any questions so far? Lots of questions, I would imagine, but the main thing which I want to try to give you here is the intuition that when you're developing your model around mode choice, try to make sure that if it is nested, try to ensure that it is appropriately captured in your modeling assumption. Okay. Any other questions? All right. So if there are no questions, then I will move to the next part of this this thing, where I'm going to talk more in depth about the transport planning process, the economic models, as well as the different types of models as well. If you remember, I said that we will discuss a little bit about different types of modeling approaches. So we'll go through that. And I'm going to take an example here in Sydney about how to go about it. All right. So this is this thing. So why transport planning matters, and we have discussed this at length, is we have a lot of avoidable congestion, and the expenditures by governments are in billions, and particularly in India at a national level, it is in hundreds of billions of dollars. So how do we actually end up uh, efficiently dispersing it? That is always the question. How do we efficiently disperse this money? So this is just some of the examples. Like the thing about the transport is, it will always be there will be always stories in the news. There'll be always stories on Twitter and always stories on LinkedIn about how bad the congestion is and how people think that they could be spending the money better, right? So that is what this whole process is about. Any questions? All right. So the transport development process. So generally you have 3 stages. The first stage is the planning, then the detailed design, and then the construction. Where most of our work and our discussions are sitting today is in the planning process. All right. In the planning process, first of all, we need to identify the problem. So for instance, for a city, the problem might be mobility of people. All right. So every city ends up developing a comprehensive mobility plan every 5 years at least. In that, it identifies that where are the main choke points, what are the main issues for public transport, etc. Right. So that is the first piece, which is the problem identification. Then you come up with design options, which is basically also the same as scenarios. So the different scenarios. So for any problem, like for a bottleneck, you could end up developing solutions all the way from increasing the number of lanes to having flyovers to actually shutting down that road and making it pedestrian or all pedestrian. These are all valid and viable design options. But the question is, which one makes sense and which one would actually provide you the most benefit? So that's where the appraisal comes in. All right. So you're able to go through different scenarios, compare them, and say that this is the best. Any questions on so far on this? So that is fundamentally what happens at a transport development perspective. And in all of this, you have transport planners, engineers, and economists. And I would always argue that the best transport professionals whom I've seen are able to span across these 3. When I say span, they're able to understand the problems, what a planner has. That means get involved in the problem identification while developing engineering solutions and thinking about the economic implications of it. Because otherwise, what generally ends up happening is a planner would come up with really, really novel, innovative ideas and options, but it might not be economically feasible. So that is where a lot of uh, the value would sit, and hopefully that's what this course is trying to address. It's trying to create, like a lot of you are already planners or engineers, but this course is trying to get you a sense of how an economist works. How do you do appraisal? And at the end of the day, what you'll find is I think one of you had actually mentioned in the very first lecture, performance indicators. It all goes down to setting your performance indicators and being comfortable that these performance indicators are going to be changed on you. So you will come up with a certain this thing, and then the government will say, all right, but have you considered this? Have you considered that? So you have to be comfortable in uh, incorporating that. So the transport planning problems can be uh, considered across three areas. One is a policy level, which is looking at fares, congestion pricing, ramp metering, registration costs. We talked also about fuel excise, um, etc. Network level, which is more corridor and precinct planning, which is essentially associated to the comprehensive mobility plan. And local level, which is more a traffic engineer's job around intersection upgrades and road widening. Now, one thing I forgot to mention here. When we talked about a lot of these problem identifications, design options, and appraisals, we only talked about mobility of people. So if you look at a comprehensive mobility plan, almost 95% of the whole discussion of the comprehensive mobility plan is around the travel time of the commuters and the bottlenecks experienced by people traveling. Freight is usually missing in it. So a lot of cities are now coming up with a comprehensive logistics plan. Where should you put your warehouses? What should you be? What time of the day you should be traveling? How can you actually improve the logistics and goods movement in a city? Right? Any questions? Any questions so far? Okay. As well. So in transport modeling, and we discussed this in the first lecture as well, the whole purpose of all of these models is to uh, evaluate a performance indicators. So the point is you have to go with the humility that all models are wrong, right? And some are useful. So the main premise around this uh, statement, and this was made by George Box, and George Box is the one who you must have seen in statistics, you have these box plots, right? So these box plots are basically were proposed by George Box, and he's also got a lot of statistical tests um, between looking at the different distributions. But the fact that all models are wrong but some are useful, it brings the humility that every model has assumptions, and what we are trying to do is trying to the find a model that people are agreeable to, which can then inform the decision process, right? So that is fundamentally what we are looking at. And in transport, we generally look at the 4-step model, and I think all of you have talked about it. We have a trip generation, distribution, mode split, and then assignment. We have gone through demand models as well. So in the demand models, we did not focus so much on generation distribution, because generation is generally empirically determined. So let's say um, there's an office space, then you have a trip generation of or trip attraction of certain multiplier. If you have a um, trip attraction, if you have a certain residential area, you have trip production. There is not, I would say, not much science, or like when I say science, it's all based on empirical information. So we didn't spend too much time on that. You can get a lot of these through IRC or other documents, ITE in the US, etc. Trip distribution is, given an attraction and production, how do you actually get people to move? And that's where there was a discussion yesterday around looking at gravity-based models. There are other models now which we have moved away from gravity. You can actually look at AI-based models which you calibrate on and then implement it in a new region. What we basically spent a lot of time on was mode splits. And in the network modeling, and we have not spent time on network modeling, we'll probably do that tomorrow. We will be spending time on it tomorrow, is essentially looking at macro, meso, and micro. And we discussed that as well in the first class. The macro is a static model where the travel times on each link are independent. Mesoscopic is you have queue spillback, and it is dynamic. But what you're doing is you're looking at it as a flow of vehicles. So you're not looking at acceleration, deceleration patterns for every vehicle. And then the final one is micro simulation, which you're looking at for every individual vehicle. Any questions on this so far?
No, sir, it is clear.
Yeah. All right. So generally, when you're doing, so this is the first piece, when you're trying to develop, do an economic assessment or any kind of appraisal, you have to write a report, and generally you structure the report in three sections, three main sections. First is the background section, where you're actually providing the existing conditions, information about the existing conditions. Sorry, just give me 1 second. So the first part would be actually providing the base conditions, which is the existing scenario of what the problems are. So it's essentially doing a problem identification and diagnostics. The second part is basically your proposals, which is essentially your different scenarios which you're providing, and the analysis associated with that. And the final thing is the recommendation, and we will try to go through that approach in the example we're going to go through. So this is a Windsor bridge replacement. So Windsor is a part of New South Wales, which is up in the northwest of Sydney. And it's a major, so this Hawkesbury River is a major river across New South Wales, and there was a heritage road here. Now the problem is that the structure has deteriorated and there is regular floods. So one of the things which you want to think about when you're doing a lot of these bridges in your cost benefit analysis is, one is, what if the bridge is not there? But the second is also, how many times will the bridge be flooded? So if the bridges are too low, they get flooded. So if they are flooded even 5 times a year, it's a problem. So what you want to be doing is also incorporating the resiliency and vulnerability aspects into your assessment, right? So that would then determine what is the appropriate height you want to put the bridge at. Any questions? So this is uh, the current scenario. So this is the Windsor Road, and you have this bridge which goes through here, and we have come up with like 1, 2, 3, 4, 5, 6, 7. You can come up with, we've got 7 different types of um, scenarios for this region, and we'll talk through this. We'll talk through each of them and how we can evaluate, etc. All right. So there is an existing option where in the morning peak, your total travel time is 508 vehicle hours. So that is the total number of vehicles multiplied by the travel time, right? So 508 vehicle hours. So if it was 30 minutes, the travel time was 30 minutes, then you would have 1,116 vehicles. Then your average speed is 40.5. In the afternoon peak, your total travel time in vehicle hours is 649 with an average speed of 38.5. So there are all these assessments that have been performed. Now, what is the cost associated with it? So there is there's a cost, and the left one is talking about the benefit. So if you have an existing, this is 508, 40.5. Option 1, which was, if we go back, this is option 1. Option 2. So what you'll notice is each of them has different vehicle time. Now, like for instance, let's look at option 4. The total travel time. So the average speeds remain the same, right? So what is option 4? Option 4 is going through here and coming down here. So basically your travel times are remaining pretty much similar to that what it was. The speeds are similar, etc. So what is the cost for each of these? So the cost of just closing the bridge, that's a capital cost of 540,000, and you then do a present value of that from our RTA estimate, and a net present value, the present value of the increased travel costs as well. So you can do an assessment based on the cost, and you can look at the benefit to cost ratio for each of these, right? So we did that assessment, and based on this, what you'll see is option 1 and option 2 are the best. Option 4 is the second best. Even though the total vehicle travel time has increased 513. Still, option 4 seems to provide the second best thing, or third best. So this is pretty much how we do this assessment, right? We've gone through that, and eventually what was built was 1 and 2, option 1 and option 2. So which was basically you had a shared pedestrian pathway that was built around that, and there was an expansion in the road as well, right?
Yes, sir.
Now, the transport appraisal. So how do we choose which option or projects to implement, and in what order? So appraisal assigns a value of impact, that is cost benefit, and cost benefit analysis, cost effectiveness analysis, multi-criteria analysis is all part of that appraisal. And there are 3 types of assessment. One is the strategic merit test, which is a strategic business case which you put forth, that we want to reduce the travel times by 5%, or we want to have a 30-minute city, right? These are all strategic merit tests. The next one is a rapid appraisal. A rapid appraisal is doing an initial test of whether it actually makes sense or not, right? Just doing a desktop analysis of whether we should be actually looking at improving the road or putting in a public transport, just an initial assessment before you even do a detailed appraisal, because modeling is not uh, a cheap exercise, right? People end up spending millions of dollars on doing developing a model and then doing an assessment. So there's an aspect of actually um, um, doing a rapid appraisal and culling the options which you might not want to do. Any questions so far? Let me just. Again, we've gone through what a cost benefit analysis looks like, and doing a risk and sensitivity. So one of the things about this, we've also done the concept of discounting. We've spent time on that, but also doing sensitivity analysis. We discussed that in passing, but because we are making a lot of assumptions when we do our developing a model, it is important to do sensitivity associated with those assumptions, right? Those assumptions could be based on the forecast of the traffic volumes. It could be based on forecast based on the value of time. So what you do is you change it by plus minus 5% and see whether the results, the ranking are still very stable. All right. Again, we spent a lot of time on this, so I'll skip this as well. So when we were doing our benefits, we talked about travel time savings, we talked about cost savings, we talked about accident reduction, and I want to spend some time talking through how we should be looking at. So we didn't have much. We did, when we look at the demand, we did some aspect of elasticity, right? Remember the airline problem, where when we reduced the when we reduced the the price, we actually ended up increasing our revenue, right? In yesterday's class itself, if you remember, in the first class, we actually did that, where we. So when we are looking at user benefits, the total user benefits, we need to be able to capture the impact it would have on the whole demand. So this is basically telling you that a train trip from A to B is on average, is $15, which is the generalized cost. So $5 plus 30 minutes multiplied by $20 an hour. That's $20 an hour is the value of time. So if this is my generalized cost, what it is telling you is that if I reduce my generalized cost from 15 to by $1, 14, it will increase the number of trips. And as we keep reducing it, right? Sorry, so this is $30. If I keep reducing it, the amount of demand will increase. The number of trips will increase. So currently for $15, we have Q1 trips, let's assume. Now we reduce our fare, reduce the travel time to 15 minutes. So the moment we reduce our travel time to 15 minutes, the generalized cost becomes $10. And the number of people coming in has increased to Q2. Right? So yeah, my total benefit, which I would have realized, is this shaded dark green, right? Dark green piece, which is on average $5 for the people who are already there, plus the extra people who have joined will have an average of 2.5 because it's a triangle, right? So this is 5 and this is Q2 minus Q1, pi divided by 2 multiplied by Q2 minus Q1 divided by Q2 minus Q1 is half, 2.5. So these people would have experienced on average a $5 improvement. These people would have an average improvement, a reduction in generalized costs of 2.5. Any questions? Am I making sense? I'm not having very many questions. I'm just wondering if you all have, if it's making sense or not.
Yes, sir.
Or am I going too quick?
No, sir. No, sir.
So this is going to, I'm going to go through an example again of 4 options to add ramp meters to M4. There are 5 scenarios, which is the current scenario, which is the base. Then 4 additional options, 1 to 4. And the benefits we are going to be experiencing are either travel time savings and vehicle operating cost savings. Okay. So this is our example. So the total travel time in hours. So that's the number of vehicles multiplied by their travel time is 250, right? So the average travel time is 250 divided by 1000, which is 0.25, which is basically 15 minutes. Okay. So there is no, this is the current situation. So there's nothing, we can't, the concept of travel time savings, vehicle value of time, none of this makes sense right now. Then option 1, let's say we are putting a variable speed limit, or let's say we have put in a ramp meter, all right, the ramp meter. So the total travel time has become 275. That is because you have 150 vehicles more as well, right? So 1150 divided by 275 is roughly 0.24. So the travel time savings is 0.01, which is it's 0.01 multiplied by 60 is roughly 0.6 minutes, right? Is it? Yeah, 0.6 minutes. So that's basically 0.6 minutes is roughly 36 seconds. So on average, we are saving 36 seconds here. The value of time is $15 per occupant hour, right? And the occupancy is 1.4. So the total hourly benefit is value of time multiplied by the occupancy multiplied by the total vehicles before 1000 multiplied by 0.01, because that's what we'd be saving on, which is equal to 210. So you can actually identify that through each of these. So this one has 630. Here we don't have any benefits because the travel times are increasing by 36 seconds for these ones. So you end up having minus 210, minus 210. Here the travel time starts reducing by 0.03. So you end up having almost 3 times that benefit. So that's become 630. Any questions so far?
So in this option, sir, we have considered only a base year or any tentative year we also considering. And for example, for this travel time saving, we are considering in year 2020-25. So we have considered in means 2030, 35, 40 in manner, or only consider only 2020-25.
When we are doing base scenario, we are looking at the base scenario in 2025. Oh, no, 2030. Not today.
Okay. Okay. मतलब five after मतलब in base year we are considering the construction time also.
Yeah. So the first thing is when we are looking at benefits, right?
Hmm.
10 years from now,
Hmm.
the base case is basically a do nothing scenario. If you did nothing 10 years from now, what would be the number of vehicles? What would be the total travel time?
Okay.
Is how you would compare option 1, option 2, option 3, option 4 for 2030.
Oh. With the
Does
reference
that make
of
sense? So
base.
you would not be
Yes.
comparing
Hmm.
option 1 to option 1 of 2030 to the base scenario of today, of
Okay.
2025.
Hmm.
You want to be comparing them for the same year.
Okay. Got it.
This one basically talks about how you identify um, vehicle operating costs. Now, vehicle operating costs are generally empirically determined. They're empirically determined for each type of vehicle. Okay, so now you'll have a different formula like this for based on the speeds, journey speeds, for a car, for a truck, for a utility vehicle. You'll have different C0, C1, C2, and also you'll have a different um, formula for a freeway, which is basically a national highway or a highway, and a urban road, because the wear and tear on urban roads is very different, right? So that is one point. So assuming that we have these coefficients, we can also do an analysis based on vehicle operating costs as well. So very similar. Option 1 actually reduces the total distance traveled. These two increases. This one keeps the distance traveled the same. This one increases the distance traveled, and this one reduces it as well. So based on these equations, you end up with different VOCs. So this is 28.75, 28. So literally, you put in the average speed into these, and you get that. You also have the number of vehicles which you had from the previous as well, and you end up getting the hourly benefits, comparing the hourly benefits. So again, what you find is the option 4 is the best. So one point here, which I'm just kind of reminding myself, is we are normalizing the total travel distance with respect to the base year. All right. So what that means is the normalized travel distance for the base year is 1,000. So that's 1,000 kilometers, right? So what we're going to be doing is the total travel distance of is TTD1, right? So that is 950 multiplied by 1,000 divided by 950, not 950, by 1,100. You'll get 864. So you're basically normalizing the based on the distance and the number of vehicles using it. Yeah.
We also know, na, sir, which type of mode they are used.
What?
Which type of modes they are using. We you have say na, means number of people are using this.
Oh yeah. So here
So
we have assumed that it's only one type of vehicle. So this is just an assumption. So, but
okay.
if you want to be splitting it up. So this is just giving you an example of how to do it if you have one type of vehicle. If you have 12 different vehicle classes, you will do this 12 times.
For example, we are doing for the public transport that case.
Then you would have a different VOC, cents per kilometer.
Okay. Okay. For
And
individual vehicle.
yeah, right.
Okay. Got it.
And you'll be using different vehicles also. So so the number of buses you'll be taking, right? So that'll be another thing.
But the procedure will be same.
Yes.
Okay. Got it.
I'm trying to say, yeah. So yeah. So one of the questions which we have always we are asked is, what is the what is the wider economic benefits, right? What are the wider economic impacts of um, uh, of our projects? So what does a wider economic benefits mean? So if we look at what we have done so far, we have only looked at it from a vehicle perspective or an individual perspective, and the only thing that shows up in our economic assessment is travel time or the vehicle operating cost, right? So it's either travel time savings or vehicle operating cost. But when we put in a road, there are other implications. The other implications as it creates jobs. Because the travel times have reduced, people are starting to live farther away. Accessibility. It also reduces logistics costs. So you have a reduction in um, what I would call uh, you have reduction in prices of different commodities, because a big portion, almost 30% of the cost of any product is associated to the logistics cost. So if you are able to reduce the cost of logistics, you can potentially reduce the cost of that goods by 30%. The moment you reduce that by 30%, the demand increases. So there are wider economic implications as well. So how do we account for that? That is the question. That is what we keep getting asked. So those wider economic benefits are experienced by people, but also by industries, right? By the land market, the labor market, and all of that. So let's go back to the example of this generalized cost. So we had $15 and $10. So this area gives you the total economic benefits, but it is only associated to travel time, right? But what really happens is that the demand curve also shifts. So originally, if the demand curve was here, because of the reduction, the reduction in prices, the demand will also increase. So the demand is increasing. Sorry, the demand is increasing, but the demand curve itself, will increase. So you'll end up having a more benefits here. And this is what a wider economic benefit means, is that the entire demand curve shifts. So how do we accommodate for that? How do we accommodate and how do we model that the entire demand curve is shifting? Any questions? Any questions?
Sir, are you mentioning that we are increasing the travel demand timing, so our economy is also the increases?
Correct.
Okay.
So the moment so that's what the demand curve. So the shift in demand curve is basically saying that because I put a new service in, the entire economy has increased. Because the entire economy has increased, the demand is going to increase.
But
So
but
it's
yes.
not only associated to price elasticity, but it's associated to the entire economy actually improving.
Yes, got your point, sir, but it is on the base year, right? After further, the congestion will be increases. As you already said
Correct,
that,
correct, 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 correct.
yeah, as you already mentioned that if you propose any flyover, the tentatively 5 to 6 year will be proper traffic will be flow. But after 5 to 6 year, there will be huge congestion in start. So the
So
increasing delay in travel time. So is also
so
affected
we
in.
generally, so when we are doing that, right, like when we do
Mhm,
the congestion coming in, we
mhm,
actually we model for the 6th to 7th year. So when I'm saying 15 minutes, it is
mhm.
not that it is in free flow conditions. It's actually 15 minutes after congestion has shown up.
Okay.
But so that's what I'm trying to say, is that it will still remain 15 minutes, right? The 15 minutes. But
Mhm.
what is really happening is that the entire economy is improving.
Okay.
Now, because the entire economy is improving, now has increased, the demand has increased. So think about it as induced demand. You put in a new road, there's induced demand.
Mhm.
That means your economy has grown. Now, because of that economic growth, it might not remain as 15 minutes, it might become 20 minutes, but you need to model that. And that's where we are going to talk about CGE models and all of that on how to model it. But that is what we are trying to, I'm identifying a particular issue which we need to consider.
Sorry, sir. In this modeling, we are which type of software generally use means uh, Visum or Visim? Visum, I
So,
think so.
so two things, right?
Yeah.
In Visum,
Hmm.
do you have the whole demand curve shifting? No.
Okay.
You generally have an OD,
Hmm.
you change the roads, and the there is shift in traffic. But it's
Hmm.
not like your entire demand is changing
Okay.
and the prices are changing and where people are living is going to change. So one of the things you might have also observed is the moment you put in a new road,
Hmm.
like here, like I was trying to, the moment if there was no road, right, that people are living in these high density areas, right? But the moment you put in a road, there might people will move here, people will move closer to the roads. So and then there will be new industry sections which that will also get created. So your demand curve is going to move up. That is something which is not accounted for Visum. In Visum, endogenously, you can. So what you do is you do an analysis before and you say that because you have put in this road, we are
Hmm.
expecting a growth in economy by 5%. So based on that, I forecast that the ODs here will change,
Hmm. Okay.
right? So but then you implement those ODs and then evaluate what the benefits are. But in transport economics, we have something called a CGE model where it tells you what the ODs will come up. The ODs will come up on its own, the new ODs.
Okay, sir. Got it.
So in wider economic impacts, there are a lot of aspects which we want to be considering. One is looking at the market imperfections such as taxes and monopolistic firms, and externalities, of course. Like one of the externalities you have is accidents, pollution, etc. And but market imperfections around taxes and monopolies are a big one, which are sometimes really hard to pick up on. Now, the common wider economic impacts are because of agglomeration of externalities, labor market taxes, and market with imperfect competition. There is significant, so in fact, the way to evaluate wider economic impacts change from study to study. In fact, some of them use input output, and we'll talk about that. Some of them use um, uh, something called multipliers. What they'll say is that if you have done a $1 billion investment, then there's a multiplier of for every $1 million, there's going to be 3 jobs that are going to be created in the economy. So there are different ways of actually recognizing and measuring the wider economic impacts. Any questions?
Sir, I have one question.
Yes.
Uh, when we decide that this is the two-lane road or four-lane or two-side carriageway, so how does it impact the economy and as well as the travel time prediction, or what are the economies we are studying?
Can you
So
ask
does
that
it
question?
relate directly or in the indirect way? Because while doing a life cycle assessment and life cycle cost analysis, we do consider the this part.
So when you're doing the life cycle assessment, it's basically the cost, right? So essentially, you're
Yes, sir.
evaluating the cost. But to do the benefits, how are you looking at the benefits? The benefits might show up as vehicle operating costs, like so the reduction in vehicle operating costs. Because if there's already a two-lane road, can you tell me a little bit more about the particular scenario you're talking about?
So now, for example, I'm planning a road for state highway. Let us consider a state highway, and now I'm doing the life cycle cost analysis. So
Correct.
for that, if I want to consider a traffic system, so I'm not much considering traffic system, but I'm more considered about the sustainability parameter, what type of material it is has to be used, what is the operational cost, what is the construction cost, what is the cost at the demolition state, right from initial phase to the end phase. So
Yeah.
in that case, how can I use the traffic analysis one, and how can I use this economic or vehicle let's say vehicle benefits?
Okay. So let us break your question apart into multiple pieces, right? So it goes back to what are the benefits? What are the places where you're trying to define your benefits? So when you're doing an upgrade of the road, um, well, let's say the two-lane road remains two-lane road. We are not going to change that. We're not increasing the number of roads. So there's no impact on
Okay.
travel. So there's no impact on travel time. So there should be no benefits we are identifying from the travel times. Most of your benefits will come from the vehicle operating cost because you are reducing the wear and tear on that. Number two. Number three is you mentioned sustainability, sustainable materials. So when you're using sustainable materials, they the cost of actually the cost of uh, the cost of uh, uh, getting rid of it is quite high if it is not sustainable. So that is an aspect which you can incorporate into the benefits. So if you look at the cost at the end of life cycle versus the cost of at the end of the life cycle for the material you're using, that is another benefit you would observe. Correct?
Yes, sir.
So that is where you would actually find the benefits. Um, yes, you're creating jobs, but will it create long-term jobs? No. It will only be creating jobs during the construction process. Will it are you going to create new industries because of that? No, unlikely, because it is not going to substantially change the logistics cost. So you can keep this benefits analysis very simple here. Does that make sense? You're not expecting a wider economic impact analysis. I'll give you I'll give you another example. You must have heard about a recent, I think it was 3-4 months ago. They used lignin, from biochar. From uh, have you heard of lignin? The it is a sticky material which comes out of when you take
Vegetables and all that.
bio waste.
Yes,
Yeah, if you take bio
bio
waste
waste. Yeah.
and you, so what they've been trying to do is trying to use lignin and replace tar.
Okay.
Okay, so now it's a sustainable material, right? Now, where are the benefits showing? The benefits will be, first, of course, that I don't think that there's going to be any impact on the vehicle operating cost. Yeah, because if the road quality will remain similar. Okay, so now there's no impact on travel time. There's no impact on um, um, no impact on vehicle operating costs. But there is a reduction in us importing tar and importing oil to produce tar, right? So that can be captured. This is second piece, that you won't be needing tar into for future maintenance and operation. So you can incorporate that, right? So you can look at the life cycle from that perspective. The third one, which is interesting, is there were the production of lignin never existed in our economy, correct? So you're creating a new industry.
Uh-huh.
So you can actually incorporate that. Lignin is used for other factors, other things, but that that whole industry now is going to be is going to support this. So it's going to the use of lignin on roads is going to support that industry, which is going to increase its production, which will result in more jobs and an increase in GDP as well.
Okay. So, sir, in this, do you have any idea or reports you have seen in which all this carbon emission is also seen or observed, like for lignin and all thing, standard way,
So
standard report?
I've seen some UN reports, and usually the way it is done is based on the carbon credits, the cost of carbon credits. So what
Yes,
you would
yes,
do
sir.
is, so y- um, you would what you would do is you would look at the reduction in the carbon footprint over the life cycle, right? Um, yeah, you would look at the reduction in and multiply that with the current carbon credits, right? Like the rate of carbon credits. So I think it's going at around $30 a ton right now, the carbon credits. So you take $30, multiply it with the number of tons you're going to be saving every year, and also put a discounting rate. That would be my initial way of incorporating that. Now, when you end up doing this, people will argue with you that, oh, we don't know, there's a lot of uncertainty in the in the carbon credit cost. So there's a lot of uncertainty. So it can go anywhere from, sometimes it goes down to $15 a ton to almost $75 a ton. So then you have a discussion. All right, what is a more comfortable thing which you would be comfortable with? Based on our assessment, we are using today's price. Based on other reports, we can take a lower value. We can take even 20% lower, and then do that and do the analysis. So so the places where people tend to have a lot of arguments is around those assumptions.
Yes, sir. I've gone through this actually.
Yeah. Does that make sense?
Yes, sir. Yes, sir.
Oh, but so
Sir,
what
would you
in
suggest me to consider vehicle operating cost in this? Or I should put a boundary condition for that? Because otherwise it would be a too large one, I guess.
no, you can, but I don't see why there would be an impact on vehicle operating cost, right? So
Yeah.
the quality of the road with the tar and the
Mm.
quality of the road the of the road with lignin is supposed to be almost the same. If I relay the road with lignin, so it's going to be
Okay.
smooth. So there should be no impact on vehicle operating costs. Now, one thing is that they might both deteriorate differently, right? So when the deterioration level starts happening, then vehicle operating costs start playing out. So if let's say it's the other way around, if the but based on initial studies, even the life cycle, right, the period of deterioration, but we don't have enough empirical analysis on this on very many roads. But let's say, for example, that the tar road or asphalt road uh, takes 10 years to uh, it has to be relayed every 5 years. Every kilometer has to be relayed every 5 years, but we might find that it has for Lincoln it has to be relayed every 3 years. Now that means there is a period where of 1 year where the quality of the road might be very bad, so you might want to incorporate, but I don't think you should be doing that. I think vehicle operating costs won't make sense in this.
Okay, thank you so much.
Yeah. But how did you solve for the problem around the $20 or $30 on the carbon credits?
So I was thinking of just, as you said, that lower percent of 20% and higher of, so I was thinking of doing lower to 30 and higher to 30.
Yeah,
So,
best is to do sensitivity
yeah,
analysis. And when you do the sensitivity and sensitivity analysis, you end up getting
graph,
getting a band,
yeah, yeah,
and just compare the band between your two options.
yes. And that will give me the probable value of the current scenario.
Correct. Yeah. Yeah. Good. There's a there's a very interesting video by Richard Feynman on why two magnets repel each other, right? So so if you're building a model or doing any kind of learning, you should try to gain an intuition of the problem first, and you can ask the question why. You can ask the question why, but you can only go as far to reasonably answer it. So it's a very interesting um, thing. So sometimes when people are being unreasonable about asking why are you making this assumption, uh, what it is, you can this particular video is maybe um, I'll put it in the link, uh, and you guys can look at it in any other questions or thoughts. So what I'm thinking is let's take a bit of a break, and what I want to do is go through some of the in the next this thing is go through some of the uh, ways of actually doing cost analysis, and I'm taking an actual example with the DFC, with the railways. We've got some actual railways data which I want to kind of go through the different types. Most of the because it's a very different, like in all your analysis so far, what you all do is, and most of what you have kind of experienced has been doing the economics based on people, travel time savings, people. But there are different concepts when you look at logistics costs, and we will spend some time on that.
Yeah. Sir, one request to you, sir. So
Yeah.
in morning that you show that PPT, can you share with us?
Which one?
First lecture, morning starting, the eco analysis,
Okay. Okay. I think I
NMI
have
model,
all. I think I
NMI model.
have, no? Yeah, I have not created. So this is today's lecture is probably a new. I have recreated it based on our discussions over the last 2 days, but everything else is exactly the same as what The lectures that have been slides that have been provided to you.
Uh,
Can
Actually,
you
sir,
check?
yeah, I also checked, but sir, that Excel that you are explaining yesterday, that
Yeah, yeah.
calculation, that part you are mentioning in PPT, only the final result.
Oh, yeah, yeah, yeah. Okay, okay, okay. Yes, yes. I'll send
That,
you PPT. Oh, so yeah,
yeah,
the example, the tutorial
yeah,
example
yes,
PPT,
sir. Hmm.
and the data I've sent you. No,
Yeah, yeah, yeah. Data we have got it. Yes, sir.
you got both the data.
Yes, we have tried our own, but we did not get any final output. That's why we did not
Okay,
compare it. It is Prof is
okay, okay. I'll send
right
you
or
this.
wrong.
All good. I'll send you this.
Yes, thank you.
Thank you. Yeah, let's take maybe if you don't mind, can we start in half an hour? If you don't mind. All right, sounds good. Thank you.
Thank you, sir.
Sustainability, but in the last lecture. So let me share my screen now.
Sir, hello, hello.
Hello, yeah, yeah. Any questions,
Yeah,
Manish?
sir, I have one question regarding that simulation.
Yeah.
You are mentioning the micro simulation and that micro analytical simulation. What do you mean by that micro analytical?
Microanalytical is when you have, I'll give you an example of a microanalytical. So have you heard of Sidra?
Yeah, Sidra and Synchro.
The Sidra and Synchro. They are called microanalytical because what it's doing is uh, the 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 delays, like when you do the traffic signal synchronization and all of that, the
Okay.
delays are solvable. You can actually solve it solves the systems of equations.
Okay. So
So it's a
it is most interlinked with traffic signal designing.
traffic, but usually nobody separates it out as micro analytical or micro. So people put micro analytical in the micro simulation, but
Okay.
micro analytical sits just like it's basically problems which have an analytical solution.
Okay. Got it. And one more, sir. In trip distribution, you are mentioning that there are AI-based model which we
Correct.
can finding the attraction and production. Can you please tell that name, only name, so I can research it?
So people have used neural networks. I've seen some neural network models looking at estimating trip um,
Okay.
uh, trips from based on production attractions. Yeah.
Okay, sir.
I can't give you the references on the top of my mind, but I remember reading them. Uh, and this was probably 2 years back.
Okay, sir.
So if you just look at machine learning approaches
Hmm.
to trip distribution, I think there might be a review paper also.
Okay, sir. Okay, I go through it. Okay. Thank you.
So the next thing which I want to talk about is so there's a recent work which we have been doing, and I thought it might be interesting to just share that. It is not final, so please do not use, or this is none of this is um, what I would call uh, finalized. So there's a lot of, so this is not full. This is not something I would go to the government and say that this is what it is. But the whole purpose of me sharing this is going through how we are analyzing it and how we are trying to do economic impact assessment and evaluating each of them, right? So the first thing, you've all heard of the dedicated freight corridor in India for the railways. Hello.
Yes, sir. I heard about it.
Yeah. So the dedicated freight corridor was set up uh, by the Indian Railways to actually support faster, more reliable transport of the freight goods. So one of the things which the freight industry was finding on the railways was that a lot of it was getting stopped and was getting affected by passenger traffic. And it was affecting the reliability uh, uh, and the on-time arrival of these trains. So the first question was, is it reliable or not? So the first thing you do is you end up doing a distribution. You look at the speed distribution of your trains on the DFC versus on the Indian Railways, right? So what you can find is, let's try to look at. So this is part of the diagnostics, right? So this is what we are just kind of talking about it. So this is part of the diagnostics. So what we find is that the average speeds on the DFC. So DFC is green. So average speeds on the DFC is higher, and it's close to around 32 kilometers per hour for 24-25. And this one, the average. So this is the mode, but the average is uh, around 18 because it's got a heavy tail also, 15 to 18 kilometers per hour. This is what we find, and the standard deviation is also very large. Okay, so here it is much tighter. This one has a heavier tail. You can look, it's got a heavier tail. It's skewed to the left and got a heavier tail, as opposed to this, which is nice and symmetric and is much more tighter. And what we then looked at was, are there differences between the EDFC, which is the Eastern Dedicated Freight Corridor, and the Western Dedicated Freight Corridor? And what we find is that the EDFC is ADFC and WDFC have very similar profiles. So a dedicated freight corridor is a dedicated freight corridor and has good performance from a speed and distribution standpoint. Then what we did was we looked at the coefficient of variance. So what is a coefficient of variance? Basically, it's standard deviation divided by mean speed. So what it's telling you is, given a mean speed, what is the standard deviation? So you want the mean speed to be high, but the standard deviation to be low, right? So what you want is generally your coefficient of variance to be going down, right? Standard deviation should be lower for the same mean speed. So again, if you look at DFC versus IR, the coefficient of variation is quite low compared to IR. So what it's saying is that the standard deviation is also low, but the mean speeds are high, right? So that's why this is lower than the IR, the Indian Railways. So these are some of the statistics which you would generally try to evaluate and compare. Then we looked at developing a reliability index. So how do you do reliability? Now, one of the things you have is you have travel times. So usually you have travel time and then you have the standard deviation of travel time. Okay. But they are happening. So each trip has different travel length, right? So what you do is usually you do the calculations in pace, which is hours per kilometer. Does that make sense? So it's basically the inverse of speed. Any questions?
Sorry, sir, I have one request. Can you once more take up
Yeah.
actually my power? That's it.
Okay. So the concept of, so the first thing is, when you're looking at reliability, you can look at reliability based on speeds, but what is generally useful is you're looking at reliability in terms of travel time. So what is your mean travel time and how, and what is the standard deviation of your travel time? Okay. But the thing about trips is there are different trips are experiencing different distances. Does that make sense? So there'll be some trips which are shorter, some trips which are larger. So how do you actually then evaluate this from a reliability perspective? So what we do look at is something called pace, which is actually the inverse of speed, which is what it's telling you is travel time per kilometer. So what is the number of hours to go per kilometer or number of minutes per kilometer? So what this distribution is showing is the number of hours per kilometer. So usually what you're finding is that the DFC has a lower hours per kilometer and is tighter. So the gray is the the reliability. Sorry, DFC. And the red is IR, Indian Railways. Okay. So what we are doing is we are able to then say that the pace, which is the hours per kilometer, the is smaller for DFC, right? That's what you want. So that means it takes less amount of time to travel a kilometer, but also it is more reliable because the standard deviations are lower. And you can see that here. So in 24-25 on DFC, it took 0.038 hours per kilometer, and the standard deviation was only 0.028, right? So they're almost equal. And for IR, it was 0.132 is the pace, the hours per kilometer, and the standard deviation is 0.133. All right. So what you can from pace, and I'll explain to you why pace is important. Why can't we do this with speed? And I'll explain to you. Because like you have value of time in for travel time savings, you can actually have value of time for freight goods as well. And you have to be very systematic about how you're defining those value of time. And we'll talk about that in a moment. Any questions about this so far? The concept of pace. All clear?
Space is more or less about speed.
Yeah, it's the inverse of speed.
Okay. Okay.
All right. So one of the things we wanted to do then is look at cost savings. So I'll not go through the stakeholder interviews. I'll go straight to the idea of working capital. Okay. What is working capital cost? The working capital cost is that if you take any raw material, right? Instead of that raw material actually being transported, if it's not being used, if the raw materials are not being used, right, then it is a waste. So let's say there is coal, but the coal is just sitting. It is a waste. So the point is, can we reduce the cost of working capital? Because that capital is just sitting, right? It is like I have money, but it's just sitting. I'm not getting it to be used in anything. So the idea of in economics is to have any capital, you want it to be worked. You want it to go into the economy to work. And you want it to go into work as quickly as possible. Okay. So the way you generally do working capital is there are two parts to it. One is the travel time savings, which is the fact that if you have reduced the travel time, then it has gotten to the production plant and it can be used faster, right? So that is the savings from the capital cost. So what you do is you look at the travel time between the travel time on what it would have taken on the Indian Railways minus the travel time on the DFC. So that tells you the travel time savings, right? Then I multiply that with the commodity value per unit, right? So let's say I'm using coal. So coal's value is 10 rupees per ton, right? So that is the money. So that coal is almost 10 rupees per ton is just sitting. So that is the per unit cost of that commodity. And then you multiply that with the total units moved. So how many units was moved? So what was the total volume that was moved? So that gives you the total inventory, the total capital that is being moved, and the fact that the travel time has been saved. And R is the interest rate. So we generally assume 8.5% per annum. So that is you convert that. So per annum, you convert that into per hour. It tells you what the interest rate is, and this is based on simple interest. So what is that? So what you're doing is you're trying to look at the fact that how much of that is being saved because of that travel time. Similarly, you can have that for capital cost savings for reliability as well, right? So that is basically sigma p IR minus b sigma p DFC multiplied by distance, because the if you remember, uh, uh, the distance is the trip distance. So because the standard deviation is the standard deviation of pace, so it is hours per kilometer. So I have to convert that into hours. So I multiply that with the distance, and then the rest remains the same. So what you end up having is you have a travel time savings and you have a reliability savings because of reliability. So why do you assume that you have reliability savings? What a lot of companies do, right? And we do that even at our home, right? Like uh, we hold on to rice. If we go into our kitchen, we have rice. We are holding on to that rice, and the reason a lot of time hold on to we have a stock of rice is because we don't know when we will get time and go to the shops to pick up rice. Ideal would be if the rice was coming every day with reliability, but you're holding on to it. So similarly, power plants or anybody would try to hold on to it, hold on to a certain amount of it, just to make sure that there is a 95% confidence that the amount of raw materials they need will exist. So you generally take the 95th percentile of that standard deviation. So you multiply that with 1.64 to get, and that will give you the time. And that difference will give you how much is the savings from reliability perspective. So that comes out to be around 1000 crores. So you have the travel time savings gives you around 112 million INR. And the savings gives you 902 from reliability. So the majority of your savings comes from reliability, all right, from a working capital cost perspective. And the final thing is, if you add both of them up, you get 1000 million, which is, I think, 101 crores. 101 crores. Am I making sense? So this is just one one aspect of the economic cost savings for logistics. Any questions?
No, sir.
Um, the next part, you have something called warehousing cost. So this is the working capital, right? So the fact that it was not being used, but then you're also storing it. So you're paying rent on the storage of that. So the storage cost, the warehousing cost, is basically the you multiply the rent, the distance, and the volume with mu plus b sigma p. So that is mu is the amount of time it would actually be held in your held in the uh, held at a warehouse. So you're paying rent for that. And if I just look at the savings coming from rent, sorry, just give me 1 second. Just give me 1 second. Hello.
Yes, sir.
Okay. Uh, right. So the second part is you also have an operational cost saving, right? The operational cost saving deals with um, how many less wagons you would need, right? If you were if you were delivering things faster. So because things are you have to provide it at a certain rate. I'll try to explain to you. Give you an example. Let's say the average speed on a road is 10 kilometers an hour, right? And you want to keep an average headway of 5 minutes. So one of the underlying fundamental things is you want to keep an um, um, average headway of 5 minutes. Now, if your average speeds were at 60 kilometers an hour, you would need less vehicles to be running at 5 minutes, as opposed to if the vehicles were running at 10 kilometers an hour. Am I making sense?
Yeah, yes.
Right?
So you are prioritized to freight vehicles compared to passenger.
So that is there, but what I'm trying to say is something more fundamental. Is what is this operational cost saving? So one of the big things which you're always going to experience is that people are going to try to, and not people, but we have to be very, very careful about not double counting, right? So people will say, okay, you've already done this here in the working capital cost. Why are you including this in the warehousing cost? Because you have mu plus b sigma p here, and this is mu plus b sigma p here as well. Why? Why are you doing that? And the main reason for that, the main reason we have to look at it that way, is this one is basically associated to the rent, the warehousing cost of the rent. The rent the companies will save. This is the cost associated to the working capital, the fact that it was not being used. But then there is a third thing, is if your speeds are higher, you can actually maintain the same headways with a smaller fleet.
Yes, sir. Got it.
That's basically what it is, and that's where your operational cost savings are coming. So it is what you can actually do is, because you have so many GTKM per day, this is the number of wagons, but for the same amount, how many wagons would we need? And based on that, you can say that, all right, the wagons saved is around 55,000 wagons per day, which is roughly around 9,659 million INR, which is almost equal to 1,000 crores, 1,000 crores. So these are one of the few pieces of the puzzle of how we end up doing. And this is an actual project. We're doing an actual economic assessment of this, and it has taken us months to actually come to these decisions and agree on the methods for this. Any questions so far?
So that wagons you are mentioning, there are total number of wagons, right? We are not mentioning the how many railway trains we are required.
Yeah. It's the number of wagons. So I mean, usually um, you do your analysis, your operational cost savings per wagon, because that's what you pay for. So the
No,
wagon
sir.
cost is
Actually,
rupees 479 per day.
okay. Are you mentioning that we have maintaining this proper headway between the two rails?
So yeah, so
So
that's because the speeds have increased, right? So because the speeds have increased, so
mhm,
let's say in IR we had 285.4 million JTKM per day on that stretch. So that needed 48,000 wagons. But because on the DFC it is faster, you might, this is the number of GTKM per wagon that is being charged. So you are actually getting a wagon efficiency because of that, because you're faster. So you can actually, because the speeds are faster, you don't need to run. Does that make sense what I'm saying?
yeah,
So you were only carrying 5,873 tons kilometer per wagon on the Indian railways, as opposed to 24,747, just because the speeds were larger.
yeah,
And you need a very fewer number of wagons
yes, sir.
because of that.
Speed will increase, travel time will be always
Reduce.
decreases.
Exactly. So, any questions so far on this? I wanted to actually talk through a little bit of the logistics costs as well, because all of what we have discussed have been around travel time savings, all of that. But when we do a full CGE model, we will talk through all of this. So this is all, if you think about it, they're all small pieces of the puzzle. Now, these puzzles actually all come together and affect each other. And we'll talk about that tomorrow. All right. Now, what I want to do is shift gears into safety. Okay. So let me. And this was one of the questions you had about in the, I think it was in the very first class. How do you do economic assessment on roads for safety? Correct. So the first thing is, when we are actually doing any road safety study, there are two approaches we undertake. One is a before and after study. So we put an intervention. So we do a before study. Before we have the number of crashes for a certain period of time. We have that data, and then we do an intervention and see afterward what has been the reduction in crashes. All right. So the problem is, to assess whether a crash countermeasure has worked or not, you need to estimate what would be expected to happen in the future if no action was taken. Right? So what do we mean by observational? What do we mean by experimental? And we will also talk about cross section. So observational can be before and after versus cross section. So what cross section means is that usually what you might also have is, let's say you're looking at interventions at an intersection, right? And whether or not they're working. So what you would do is you would look at similar intersections where in which with similar AADTs or whatever, and places where there is the intervention and places where there's no intervention. So if you're looking at a four-legged intersection with four-lane roads in each of the approaches, you have another one with four-lane up this thing. And the only thing you have changed between those two is the amount of all red time. Okay. Am I making sense so far?
Yes, sir.
Yeah. So the only thing you're changing between the thing is the all red time. So because they are very similar intersections, the two intersections are very similar, you can evaluate. You can actually evaluate what the impacts are because of those two. Right? So experimental is more that you put in an intervention and see what's happening before and after. So now let's take this example. An agency plans next year to implement a crash countermeasure that will reduce crashes by 35% over the next 3 years. You need to estimate the benefit of this countermeasure. How would you go about doing that? Right? So this is giving you the crash data for the last 3 years. So I've taken an old 2008, 2009, 2010. Observed crashes was 30, 19, and 21. Right? This is the previous, the last 3 years. Now, if I had taken more, so if I take the average of this, that will be around, this will be 40 plus 37. Is that right? 70 by 3. That is around 23. Yeah, 23 point something. Now, if I take more data, it will be less than 23 because you're also getting a few 17, 14, 9. So this will be 22 plus 23 is 45, 51, 61, 67, 77, 86, 100, 117, 117 plus 70 is 187. 187 divided by 10 is 18.7. Right? So my average is 18.7, while before it was 23 point. 23 point something. So the difference in crashes is almost up to by 5. So there were almost a difference of 5 crashes per year. So one of the things about any data set is that there is a regression to mean. Like, so the more data you get before, there is going to be, you get a better this thing about to the mean. But also the other thing that is happening is maybe that the ADT is also increasing, right? So if there are more vehicles that are getting into, that are on the road, there's a higher likelihood of crashes. So even if the likelihood of crashes are the same, because the likelihood, the probability was the same, and there are more vehicles, you will observe more crashes, right? So let's say if the likelihood of a crash is 1% or 10%, and you had your ADT was 100 before, so you were expecting 10, but now your ADT has increased to 1000, so you'll observe 100. Correct? Now you can't blame the countermeasure because of that. It has nothing to do with the countermeasure. It has to do with the fact that the ADT has increased. Yep. Am I making sense?
Yes, sir. Yes, sir.
Excellent. So this is just giving you the long-term average. That's around. This is just giving you an example. This is the long-term average, and you're moving between this thing, and then this is the 3-year average. And this is part of the random error. You can't take that as. So how do you accommodate for all of this? So what you should be looking for. So when we are looking at the true safety impact, we should not be looking at this 3 years before and 3 years after average. We should be looking at it compared to the true mean, the long-term mean versus the actual 3-year after average after, not the before. So there are statistical methods used for this, and one of them is called the negative binomial distribution and zero inflated, because you have a lot of data where you don't have crashes. So we'll talk about that. Any questions? Does this make sense, what I've talked about so far?
Sir, is there any example so we can understand?
So this is the example I was kind of talking about, right? Like, so
Okay.
let's take this example only. We are getting on the long term average is around 3.5 crashes per year. Okay.
Okay,
But
sir.
if I take only a 3-year average, because of randomness, I'm getting around 5 crashes per year. Okay. In 2003, I apply an intervention. Okay.
Mm.
And the 3-year average after is showing to be around 2.8.
Okay.
So 3.5 minus 2.8 is 0.7. So there's been a reduction of around 0.7 divided by 3.5, that is 20%. There's a 20% reduction. But if I had taken this, which is 5, so 5 minus 2.8 is around 2.2. That becomes quite a large impact. Yeah. So what we are trying to say is that we'll only be looking at we should be trying to identify the true safety effect, and that is the fundamental first problem which we try to do when we are doing any kind of safety impact assessment, is what is the true statistical measure of the difference. All right.
Yes, sir.
Regression to the mean. So one of the things you'll find is that high crash locations are chosen for one reason, because the number of crashes are high, right? But the reason why they can be high is it could be just a random variation like what we observed here, right? Or is it truly high? Is the mean really high? And the second point is, even with no treatment, we could expect that the average could reduce. And the reason, and we will talk about this as we go through the lecture. The reason we can observe this is because let's say the ADT has dropped. The average daily traffic has reduced. Because of that, you might have a lower crash rate. So you have not done anything. So it has nothing to do with anything except that the ADT has reduced. And there are a lot of these other factors that might be influencing the likelihood of crashes. So we need to account for that. And we need to account for that properly in our statistical methods. So this gives a regression to mean. So this is just giving you the same example here, right? So you might have suddenly your crashes increase and the next year the crashes reduce. It has nothing to do with this thing. It's just a random variation. And why those random variations are quite high in percentages is also because the crash numbers are low, right? So if you have two crashes per year and they suddenly increase to 5, let's say here it was 1 and it increased to 5. Does that mean that the crashes have increased by 5%? No, it is just a random variation, and so not 5%, 5 times. So that's almost 500%. So it's just, you have to be very careful about that. So one of the first things which people tried to do was apply how do we solve this imprecision problem? right? So the first thing, because the data is a discrete data, you have number of crashes, right? Number of crashes per year. What you end up doing is you use something called a Poisson distribution, right? So basically, if you have 100 crashes per year on a 3-year data, the Poisson standard error is nothing but, so 100 divided by 3 is the is giving you the square root of 100 divided by 3 gives you the imprecision, plus minus 5.7. However, if there was one crash per 3 years and 3 years of data was used, what will that be? Or what will be the mean be? It ends up becoming quite high. So one of the things which there are two problems with the Poisson distribution. First is that the mean is equal to the standard deviation, and we know that with crashes, the mean and standard deviations are different. And the future conditions are also not the same as identical to the past conditions. There's always some changes happening in our network. So that is where we ended up coming up with the idea of a Bayesian method. So what is a Bayesian method? What the Bayesian method says is that we need to be actually creating something called a safety performance function, right? So what the safety performance function tells you is, for a given this thing. So this is before, right? This is before, and this is after. Sorry. Yeah, this is before and this is after. So one of the things which we want to be doing, and this would be probably the regression to the mean. So one of the things we want to be looking at is the first thing is when we decided, right, like when we looked at a before and after, what we might find is before we had say here this is around 13. So we had 13 crashes per year. That was the crash frequency, 13 crashes per year, and the ADT was only 10,000, right? It took us 1 year to 2 years to implement the intervention, whatever that intervention might be, right? We end up having a reduction to the same level, right? So we find that the crash rates are still around 13, but the ADT has increased to 2,000, 20,000. So when the observer kind of looks at it, when a decision maker looks at it, and they'll say that, oh, look, there has been no impact on crashes. Whatever was happening is now happening, and the investment we made was wrong. This is where the idea of Bayesian comes in. What you really need to do is actually look at this curve. This is called a safety performance function, and we'll discuss how it's built out. In that safety performance function, you find that for 20,000, the actual value is F2. And if you had done a linear extrapolation, it would have been F1. So you need to be actually comparing F2 to F3, not F1 to F3. If we do F1 to F3, we are overestimating. If we look at F3 only, then we are underestimating, because we'll say that there's no impact. So it is basically F2. And we develop these safety performance functions. And this is where the crash modification factor comes in. So whatever this difference is, right, the difference has happened in this curve is because of the intervention, the crash modification factor of the intervention. Any questions?
No, sir.
Okay. Is this new? Have you all studied this before?
Not much, sir.
Okay. So I'm kind of, so this is what kind of moves to an empirical base. So that the idea is you're using an empirical Bayesian method. So you're not only accounting for what happened, but what has also happened, and given what is the current situation, what would be the expected number of crashes, and looking at that difference. All right. So I think we'll we will walk through this. So how do we operationalize this? So how do we actually end up doing this? So we use something called a safety performance function. So safety performance function is going back to the example on the first day associated with, I think it was first day, where we were looking at the hilly roads, right? You were mentioning about hilly roads. How do we define the different sections? And one of the things about those sections are that these sections need to be uniform sections. They have to be uniform in terms of the number of lanes or some kind of geometry, the AADT. They're basically similar sections. So what you do is you actually regress the crashes with respect to AADT and the road length. So it's the crash frequency is basically the number of crashes per kilometer per year, right? So and you'll find different AADTs and you'll get different points on similar roads across your region, and that will give me the safety performance function. So I do a nonlinear regression, which is basically an exponential curve.
So sorry to interrupt you, but sir, is there any practical example which this safety performance for the road is applied in India?
Yes, there are plenty of them. So the idea of there is, I think there are a couple of papers that have come out of TRIP where they've used the crash data to do that. If you have, the biggest problem is getting access to crash data. And I think there is a database now called RADS. Is that right? I don't know if Raghu is not. There's a crash database which is managed by the NHAI, where you can actually
Yes,
get
sir.
some
NHS is managing the crash database now.
Yeah. So you can get a lot of those crash, and people have used that to estimate the safety performance function or the crash modification factor. So if you do a Google Scholar looking at crash modification factors in India, you will find at least, I think every year I'm seeing at least 4 papers come out in this area.
Sir, but the paper I read, sorry sir, but the database I read is not available to the public. But
I
it is
know.
available to police department, transport department.
But if you have good access through the government and all of that, you might be able to get access to that data. So a lot of universities and research institutions are able to get access to that. The biggest problem in any of what we are trying to talk about is data. So even with the reason why the data is collected is for other reasons, and then what we are trying to do is to get access to that data, and it is never easy to get access to that data. So that's one piece. I would say that almost 60% of the effort goes into the data. Once you get the data, then everything else is much more simpler. And you have to then also modify your method based on the data which you have and is available to you.
Sir, the second problem here in India is to maintain the data.
But that's a problem everywhere, Manish. So it's not like, I mean, there are difficulties in here, but everywhere, even in the US, it's a problem. Even Australia, it's a problem. Access to data anywhere in the world is a problem. And that is something which I have learned. When I was in the US, I used to always complain, oh my God, data is not, it's such a big problem. Then I came to Australia, I was always complaining about data. Then I started working in India. And then there's one constancy. Data is getting the right kind of data you want is always hard. But you will get some data and you have to make the best of it. That's how you need to look at it.
While while reading one of the paper of Professor Geetam Tiwari ma'am of IIT Delhi,
Yes.
sir, I came across through one statement that we can't rely the 5%. We can rely only 5% of Indian trash data. That's what.
Yeah. Okay. Yeah. So I think that is a paper from 2013 or 15. It's an old paper.
Yes, sir. Yes, sir. Geetam Tiwari ma'am and Dinesh Mohan sir.
Yeah. So that
Yes,
must have been 2013, 15. It's an
yes,
old paper. I remember that.
yes.
So, but the quality of data has improved, to be honest. It is improving.
Sir,
That is,
actually, I am facing problem in my area to get the data. I got data, but not got sufficient data to do analysis. But I am, but I am
so,
trying to get the data
so in
here
fact,
in Earth.
I will share you my own pain points, right? Like my own learnings. So I've done a few projects in India, and the one time I actually decided that we should collect data, and that was around traffic data. And so it has been a mess getting traffic data, right? Like counts, it's a mess. You can't trust. Like I did not realize how bad it is. Like you really can't trust the count data you get um, from the count, like when counts are done and all of that. It is it is a really real problem. Um, right now, my conclusion is you're better off running an AI model to get your counts, queuing length, all of that, than actually getting a person to uh, do counting on data. So that's one thing. So that is my learning from and how I would want to do things differently. To your point around what kind of data are you looking for first?
Actually, I sorted some crash data from Itanagar police station in Arunachal Pradesh, just like age, gender, what are the causes, what are the collision types, the vehicles, these datas which I sorted here. I got some data from 2020 to 2024, but the main problem came here that they had not maintained data from 2010 to 2020, but they are still trying to give me these data. That's what I am facing here, sir.
So yeah, even like I'll tell you, when I was in Florida, when I was doing my PhD, right? Uh, when we were doing analysis on safety data, we were actually going through reports. They were like handwritten police reports. We were going through the handwritten police reports and actually coding it up. And this is probably what 2000. I mean, it is probably a long time ago, like 2010, 9, 10. So that's probably now what 15 years ago. Yeah, so it is. If you're trying to do safety studies in a new place, in a new area, when people have not even thought about the fact that you can do such analysis, there will be a lot of manual work. And try to figure out ways in which you can use uh, machine learning or even OCR, like character recognition, to actually pull out the data. You're better off. There will be that you will need to spend 2-3 months trying to actually train those models. But once you do that, you might be able to get it to do better. And you also have then a solution which you can then take to other parts and get it and codify the data. but spend some time doing that. I think that is a worthwhile exercise to do. Rahul.
Okay, sir.
Sorry to
Okay, sir.
interrupt you.
Yeah, man.
Uh, So, but when we are saying that we need to pull out the data from AI/ML and train the model, so the question arises here: how to validate those data, whether those are correct, whatever you are taking the
So
data from it.
you'll have to randomly validate it. That's what we have been doing. Like we still, you have to randomly validate it.
Because
And
this is a question asked to me, and
yeah,
I wasn't able to answer the question because we don't have the proper data set, whatever available in the reports also. So we don't know whether those are correct or on what basis we are making the decisions.
so so let me go back uh, a step. There has to be a reason why you believe that the data is wrong. Let us not even go to the AI/ML part. If there is a police report, so I'll give you one example of where I know the police reports tend to be wrong. One place where the police reports tend to be wrong is around the location. Like, where did the accident happen? Right? The there is a lack of accuracy around that. Usually, there is a lack of accuracy around that. It is a well-known problem. Okay, so now given that, how can you use this data set? One thing is, you know that it happened on that road. You might not need to know exactly where it happened, but you know that it happened on that road. So you can look at it as a uniform section and take bigger sections and do your analysis based on that.
Yes, sir.
So 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 this is where I think we need to be able to uh, uh, I absolutely empathize, and I know exactly what you're facing. One is, and this is where there's an art of articulation in this, is recognizing that, look, this is the quality of data. The quality of the data will enable us to do only this analysis and no more. And if we want to do this kind of analysis, we need that quality of data, which we need to train up the police and all of that. But there is still a lot you can learn. So it is a matter of getting your uh, uh, getting your expectations and training up your expectations and adapting your, the word is adapting your expectations based on the quality of data we have. And the problem you will find is, and me being an academic as well, so there's a bit of a self-criticism here, is you will also find that when we are, as academics, we like to be very precise and say that that is wrong, but there's nothing wrong about it. That's what is being presented to you. And as an engineer, if you're presented with lemons, you make lemon juice. So and lemon juice is quite useful, it's very tasty. So that is how I think we need to be approaching a lot of empirical analysis and empirical approaches. And modeling is exactly that. It is a recognition. The first piece is, if you have an opportunity to do the data, do it well. My learning from my own experiences, I would do things differently around data collection for traffic. I would actually perhaps go out and ask a lot more people about what have the problems they have faced around counts and all of that. That's number one. But number two is probably my first uh, uh, my first approach would be taking a videographic machine learning model to count vehicles. But yeah, that's me. But I just wanted to share that I understand what you're saying, and I believe, like, if you're doing your PhD or you have a certain question, you're trying hard to find that particular data. But when that data is not available, recognizing that these are the limitations with it, but still you can find something useful, is a very useful task in itself.
Sir, can I like I just have a doubt. If I'm doing like AI ML modeling and I'm getting the answers, so can I go reverse engineering? So what are the answer I'm getting? Like for example, 3. So I know 1 plus 2 is 3. So in the reverse manner, first I get the models done, and then to validate it, I'm doing that 1 plus 2 is 3 or 2 plus 1 is 3. Can
So
this be a method? Because I think this is a wrong actually, but still, if you want to do the validation, some method should be opted.
what you're kind of looking for is an automated validation method, right? So
Yeah.
there are two pieces onto that. Um, One is that there is no way around actually doing a manual validation, right? And then so a lot of machine learning models have a training method which is iterative. So what you do is you do an estimation, and based on that estimation you correct it and say that this is the place which you need to correct, and it retrain the model. Every time you're able to find an error, you retrain it. So and then re-estimate and see whether you're able to get closer. There are going to be errors, but
Yeah, yeah,
so,
yeah.
so
Okay.
you need to be doing that. Now I think we are still not there. There are explainable AI models where you can actually backtrack and figure out what the inputs are and validate the inputs to that. But I don't think we are there. At least I'm not aware of tools which are reliable enough to do that well. The only thing which I know currently that I can do well, probably my understanding is a bit lagging. Probably it's lagging by a year and a half on this question you asked. But my understanding is we still do a lot of work by manually updating it and retraining the model.
Okay. Sir, many of the civil person who are working in the industry, like whenever we suggest a topic or when we say we are working on AI ML modeling and also, so the question there is that we already had a good planning system already in the earlier India, if you see. So why there is a need to inculcate the your modeling system and everything? So you can go with the manual way, which were more concise and precise. Why there is a need to do AIML modeling?
So two things. First is question them on their assumptions about accuracy and preciseness, because um, it will fall apart there. I am almost 60% sure that it will fall apart there. The second one is cost. It will be cheaper. Manual methods are more expensive than
Yeah, I
uh,
agree.
so those are the two arguments. But I think start with cost, and if you want to be a little bit more confrontational, ask them about have they actually done an evaluation based on math? Because there's again, I'm telling you my own experience. I thought that manual would be more accurate, but the enumerators and all get so bored that the accuracies are really poor, and nobody ever checks it because there's this underlying assumption that just because it's been done manually, things are correct.
Okay, sir. Thank you.
So I'll continue with so I think I have a few more slides, and I want to finish the safety performance function. So if you can give me probably half an hour more, is that okay? Hello,
Yes, sir.
Raghu, is it okay if I take 15 minutes to half an hour more?
Yeah, 15 minutes fine, sir. I guess no issue.
Okay, I'll try to. So how are SPFs derived, right? So SPFs are developed using a negative binomial regression model. So you can actually look it up, negative binomial regression model. The reason why we use negative binomial regression model is the mean and the standard deviations are different in a negative binomial. If you do a Poisson distribution, the mean and the standard deviations are, the mean and the variance are the same. The mean and variance are the same, right? So SPFs are specific to a given reference group of site and severity level. So what we generally do is we create a safety performance function for fatal crashes. We create a safety performance function for injury or we can just do it based on crashes, total crashes, right? So we have different SPFs. We also have different SPFs by different road types. National highways would have different, arterials would have different, urban roads would have different, intersections have a different SPF. Now, the second thing we always have is in a negative binomial regression model, you have something called an over dispersion parameter. This over dispersion parameter is telling you how far away it is from the mean. So right, so it's basically given by sigma, and eta is basically the number of crashes per time, which is giving you, in a way, it is the average crashes multiplied by the number of years multiplied by the number of the length of the road, and if it's intersections, it's only the number of years, right? So this is an example of an SPF. Okay, so I've written out. So this is a regression model based on a regression model for total crashes at a rural four-legged intersection, with a minor road stop control. So you have two roads, and the minor road has a stop sign. So the ADT is given. So you basically, in an intersection, your safety performance function depends on the ADTs of the two, and they have different factors, different contributory factors to the likelihood of crashes. So for ADT1, it is 0.65. So for the main, there's a higher likelihood. For the minor one, it's a lower likelihood, right? So for the same amount of ADT on the minor road, the number of crashes will be lower as compared to the main road, right? Because, and one way to think about it is because of the speeds. Now, if you remember, yes, again on the first class, we were talking about how when we define crashes, we are looking at what is the influence area of the intersection. Is it 250 feet here? Because it was in the US, we did this work. Is it 250 feet? Is it 100 feet, 100 meters, 500 meters? The way we generally end up coming to that number is doing a lot of model sensitivity analysis. So we start with 50 meters, 100 meters, 150, 200 meters, and we end up doing this. All right. Then we estimate the expected crash frequency. So we put a weight which is calculated from and I'll talk you through this. So this is the predicted accident frequency number, and then this is the observed accident frequency. So we can get the expected accident frequency. So I'll talk through. I'll give you an example of this. So the weights are given as 1 divided by 1 plus NP divided by sigma L, which is basically based on the predicted accident frequency. So let's say we have a certain ADT1 and ADT2. We put the values and we get the predicted number of accidents, right? The predicted number of accidents. Now, the predicted number of accidents is not the same as the expected number. Does that make sense? The reason is you have over dispersion, and you're trying to account for how many accidents have you observed. So you might have observed in that particular year, or in the last 3 years, you might have observed a certain accident frequency, but you need to correct it based on the predicted, and that's what the expected accident frequency is telling you. Does that make sense, what I'm talking about?
Yes.
Perfect. So this is giving you giving you a graphical representation of the empirical Bayes approach. So the reason why it's called empirical Bayes is because you are accounting for what is observed. So from your safety performance function, you predict a number, right? You observe something on the actual run. So what is your expected? you take a weighted average of that, which is based on this. And the reason behind it is you are what you're basically doing the weighting based on is the fact that there is over dispersion. There's over dispersion in your data. All right. Then you want to look at what is the expected number in the future, right? So the expected number in the future is the expected in the past multiplied by the predicted in the future divided by the predicted in the past. It's a very simple ratios. So what it's saying is that the ratio of the futures, the expected and the predicted, is the same as the expected and the past. So that's what you're doing. So the reason is you have this number from here, right? You have NE past from here, you have NP past from here, and you're going to calculate your NP future based on ADT. So you get ADT, you'll get your NP future, and you will get what your expected numbers are there in the future. So this ratio can reflect changes in traffic volume, countermeasures, etc. So, and that's where you have the idea of CMFs come in, crash modification factors. So now how can you use them? CMFs are expressed in terms of decimal factors. So CMF of 0.80 means there's a 20% reduction in crashes. A CMF of 1.20 means the crashes have increased by 20%. And how do I use this? So the moment I put a crash modification factor and I'm able to get the numbers, right? I get my expected numbers in the future. I can actually look at what is what is the statistical. I can multiply this number. Let's say this is about based on fatalities in the future. I multiply that with the value of statistical life, right? So there's I think IRC also provides some information on the value of statistical life. Raghu,
Yes, sir. We have some values, sir. Actually.
Values. I think there is.
With respect to the wage rate of the people, so they are giving.
But is it from IRC or is it from another document? But there is some numbers which you can take, and that is how you actually get to the economic value. So this is how you would actually end up how to use them. So I'm just going through this and I'll share this. So the expected crash frequency and CMFs can be multiplied together. So NE with is equal to NE without minus multiplied by CMF. So you just multiply the CMF and you get that. So the crash reduced is NE without minus NE with. That's it. And then you multiply this crash reduced with the value of statistical life or the value of losses, property losses, the value of injury, and you will get a total cost reduction, which you will get. So the CMF for a shoulder rumble strip. So there are rumble strips on shoulders, right? Is known to be 0.79. So NE with minus NE without is equal is NE without multiplied by 0.79. So there's almost a 13% reduction. Not 13. How much is this? 21% reduction in crashes. So this is giving you some CMFs based on different. It's called accident modification for different average annual daily traffic and different lane widths. As the lane widths reduce, the crash modification increases. So that means for narrower lanes, there's almost a 50%. So by reducing my lane width by 3 feet, I end up with a 50% increase in the likelihood of crashes. That's how you would try to read this. And then you can multiply. So the nice thing about this whole approach is it's just a multiplicative of different CMFs. So you can do say put a rumble strip, then increase the lane width. You do all of that and you end up with a different number. All right. So there are a lot of tools you can use. The best one is the highway safety manual. We need in fact, if any of you are doing research, we need a highway safety manual for India. If somebody can actually come up with a highway safety manual like you have an HCM for India, we need a highway safety manual for India. And there are other tools as well, like safety analysts and IHCSD. Hopefully that. So with that, I can stop. That's all I had from this perspective. Any questions?
Sir, I request you, can you please share this slide with us?
Yes, of course, I'll do that. I've been doing that. I need to share the previous lecture slide as well. I'll do that.
Sir, we got previous lecture slides, but I think this slide is not there.
Yeah, I'll do that. I'll definitely do that. Any other questions? So the reason I put this together was because of the conversations we had on the first uh, first day, where you were also asking about how do we actually do economic impact analysis from a safety perspective. So I wanted to give you a flavor around how we end up doing it. And you can actually, there are a lot of, based on, actually most of the pioneering work has been done by Geetam, Professor Geetam Tiwari and her group. I think there's also Rahul who's been doing some work there. Yeah, I think if you can put that all together, that like you can use that as an initial piece to do some analysis there. The other piece of research wise you can also do is using micro simulation using surrogate safety assessment. That is another way of actually evaluating that. But I'll send these two slides shortly. Any other questions, thoughts?
No, sir. Sir, one request to can you please share your email ID with us? So if I have
Yeah,
any,
sure. I'll put it in the list, of course. Yeah. I've been actually getting emails from some of you, so thank you for that. I'll put it in the link here. And please feel free. Usually it takes me a little bit of time to respond, so please be patient. But since you have my attention over the next few days, if you've got any questions, feel free to ask right now as well. But I'll definitely get back to you.
yes, thank you.
All good then. Thank you.
Thank you, sir. Thank you so much.
Thank you, Raghu. Thank you so much.
So afternoon session, I will take care, sir.
Okay. Perfect. I'll give you a call after this just to kind of get.
Sure, sir. Sure. Thank you, sir. We will meet again at 2:30. Yeah, thank you all.
Thank you.
About the method of transport economic evaluation, which we have done very recent project from the native Warangal side, the evaluation of the flyovers of the GHMC. So actually, they're given a kind of request to make that whatever the flyovers they have constructed will be making what actually the benefits are expected from that actually. So generally, it is also called as the benefit monitoring evaluation system. So instead of the economic evaluation system, so can you expect what would be the difference between the benefit monitoring evaluations and the economic evaluations?
in economic evaluation, we generally see the what type of revenue we get from that particular infrastructure, and the another evaluation we check the what are the feasibility of that.
Okay, so which can be understood like that, like you are going to finance a project. So at the beginning of the project, we are going to look at that what is the feasibility of the project in terms of the economic benefit or socio-economic benefit. So which means that it is indicating the project is not taken up yet. So that means the project had to fund or had to be completed, had to be operated. But in the benefit monitoring evaluation system, the project is already completed. So in the periodical way, maybe at least maybe if I'm taking like every 5 years or every once in 3 years, I need to go what is the economic evaluation or what is the economic benefit I'm expected from the project in terms of the several socio-economic characteristics point of view, all the socio-economic point of view, whether this project is fulfilling or not. So that is the idea behind of the benefit monitoring evaluation versus the general economic evaluation of your project. So the major difference is in the economic evaluation of your project. So mostly before funding the project, and this process to be identified or to be understood and to be estimated the what is the total economic benefit we are going to get from the project. So that is going to report into the DPRs even. If you are going to look at the DPR, most probably the economic evaluation also to be reported. So according to that, they're going to take a call and they're going to prioritize it. Then they're going to identify different alternatives, and these alternatives will be prioritized. And according to the prioritization system, then we'll give the ranks to the alternative. Finally, we'll select a one specific alternative corresponding to the what is the kind of benefits or economic benefits we are getting and what is the cost of the project. So that is a very systematic way we generally do the economic evaluation before execution of the project. But in the benefit monitoring evaluation, after execution of the project, what we are expected in the economic evaluation of that particular category or the alternative corresponding to the rank is really achieving or not. We are going to do it actually. So the basic understanding of what we have done here actually. So they already constructed the flavors and they requested us. So whether these really, what are the flavors they have constructed in recent days in Hyderabad, is it really worthwhile to construct, or what are the economic benefits that are expected, is it really getting or not? So that is the project actually we have done it. So that we generally call as the benefit monitoring evaluation of the flyovers, or there are different other categories of the roads also they are identified actually. So this is the overall methodology we set up. So to understand that what kind of the benefits we are expected to get from the project or maybe like the flyover. So I'm not talking about the link roads and all. I'm only concentrating on the one single flyover data, whatever I have, because this project is completed a long period ago, like almost 3 years back. So from this project, what actually we have done. So again, understand the scenario. So you have the 4-lane road. So this is the kind of 4-lane roads generally they have. I'm talking about the single scenario of a one particular flavor. So then this road might be having the junction, having the signals also, like on the both the roads or both the major and the minor, maybe like the major categories only, not the any minor. So both the roads have the significant impact of the traffic. So at present they are operating with respect to the signals at the maybe year of 2014 around. So at the 2019 they want to construct, or they already constructed the flavor at the 2019. So this is the actual condition of the current or the situation at the 2014. Okay, so at the 2019 if you see, so this
Hello,
junction,
sir. Are you moving the slide? We cannot.
I'm not moving the slide, I'm just writing on the slide whether it is visible or not. So I'm not moving anything because I'm trying to give you a background of that project what we have done.
Okay.
So
It
in
is
2000,
yeah.
so whatever I'm writing, is it visible? Somebody can confirm, because okay. So this is the condition at the 2014. In the 2019, so you have the additional like kind of flyover is there on top of the junction. So this is the kind of flyover which is going on the top of the junction. So then, so now this is the two conditions we have, before flyover and after flyover case. So then we have collected the traffic volumes, because this project they have given as the benefit monitoring evaluation. We don't know what is there at the 2014. So we don't have any single data actually 2014. But we have data at the 2020 around. They have given 2021, I guess, if I remember correctly. So this project is 2021, 2022 around. So at the 2022, we collected the traffic volume. Then we back calculated based on the growth what they have projected. So then we have the 2021 volumes. Then we back calculated the growths. Then we got the volumes at the 2014. So then what we have done again. So that is the kind of the data collection. So first we collected the traffic volume data at the 2021. Let us assume as a scenario of the 2021. So then we have also collected the travel times at the 2021. We have the emissions data. So these emission data are estimated based on the tailpipe emissions. Like if you have the vehicle, so then we have a gaseous analyzer. So then this gaseous analyzer are inserted at the back rear end of the vehicle in the tailpipes. So then the tailpipe related all the emissions data is also collected. Then we have collected from the police stations or the near police stations, what is the accident scenarios at the nearest to close to these junctions actually from the 2014 to 2021. Of course, we have also collected the user perception, how the perception of the users after completion of the project at the 2021, and what is the condition they have perceived at 2014 and what they have perceived at the 2021. So this data we collected very near to the flyover. So what are the households we have, commercial areas we have, from those locations we have almost collected 1800 to the 2000 samples almost. Of course, this data mostly we are not much used for the economic evaluation point of view, but other the data, so like we are expecting that what is the kind of benefits they have respected to the travel time savings and the travel time savings and the emission savings, and the accidents will be going to reduce because of the improvement of the road service actually. So then these traffic volumes we collected with the video data, and the travel time we collected the VBox, GPS, manual method, MyTrack, like several methods we have used to check the accuracy of all these methods together. In the emission data, we collected the ambient air as well as the fuel gas analysis. So then the method of economic evaluation, we have done it. So for the travel time, so then what we have derived it actually, the travel time savings alone we have estimated. And apart from that, we also estimated that there is it is not only improvement of the travel time after construction of the flyover from the condition of the 2014 to 2019, it is also expected there is a reduction of the delays. So these reduction of the delays will be expected. Also, there is a reduction of the fuel savings, as well as there is a savings of the emissions respective to the saving of the fuel also. Like there are two components in the delay. So there is a component because of the reduction of the delay, what is the total amount of the fuel saving cost is there, and what is the total amount of the emission saving cost is there. The same way the accident cost also estimated. And all these costs generally is relevant as the kind of the benefits actually. So any questions here? It makes sense what we have done. Like,
Sir, what is MyTrack, sir?
it is just kind of app. So if you open it, so if you are traveling in a specific road, it will track that what is the travel time according to the speed of the vehicle, acceleration, deceleration, something like that. It is just kind of simple app.
Okay.
But what actually we are expecting, so because of the construction of the flyover, so there is a kind of attracted traffic, what we have already discussed in the last previous method of economic evaluation lecture. So there is a kind of attracted traffic sometimes. So people, because of the more and more delays, so there is a chances of that there might be diverted traffic also there. So mostly the attracted traffic is very important for us. What is the kind of benefits they are achieving in terms of the travel time savings, delay savings, or even the just kind of the more there is no kind of accidents are happening on this specific road. People are interested to travel on this specific road generally. It may be related to the like there is no pothole, something like that. And there is another important thing actually, like we have the before and after improvement of the road section in terms of the signal to the flyover. Yes. So earlier you have the maybe like the 7 meters road on, like if I'm taking the one side, so there is a 2 lanes on one side and the 2 lanes on opposite side. So when it is converted into the flyover, so but these 2 lanes are already there at the below the flyover, like the bottom side or the maybe under beneath of the flyover. And apart from that, you already have the additional 2 lanes on the 2 directions on the flyover also. So which means that it is increasing of the width. So which means that so there is a kind of lot of reduction of the delays can be expected on the below flyover case as well as the above flyover case. What I'm trying to understand actually, so there is a stretch of the road, so there is no flyover actually, so then this stretch of the road having only 2 lanes. So then if I'm expecting that 3000 vehicles are moving per hour, so there is a 1500 vehicles are moving in one direction and the 1500 vehicles are moving on opposite direction. So then these vehicles are expected the different delays actually. Now this road is converted into the flyover on top of the junction. So let us assume out of these 3000, 2000 vehicles are moving on the top of the road or maybe like the on the flyover on 1000 one side and the 1000 opposite side. So remaining 1000 vehicles are maybe at ground level. So now if I'm looking there, so this whatever the road they have created in terms of the improvement by flyover case, so there is a lot of benefit in terms of the travel time savings, delay savings, just because of the improvement in terms of the road quality as well as the increasing in terms of the width also. That makes that the travel time reduced drastically, and there is a savings of the delays, and there is a savings of the even accidents or any other aspect like the fuel savings or emission savings like that. So this is the kind of information we have collected by looking of the different kind of assumptions here. So if you have any questions, we'll discuss, or else we'll move on to the next slide. So this is the complete overall methodology of the work, what we have done. So the traffic volumes and the travel times for each class of the vehicles are obtained from the micro simulation visim, because I don't have the volumes information of the 2014, because I need to estimate that what is the change of the delay, change of the travel time. For that case, what we have done, we have collected the data at 2021 or corresponding to the 2019, maybe like that. Then we back calculated the volumes by using of the growth rate. So then we have done the simulation of that case in the visim, no flyover case. Then we have estimated the what is the actual delay. Then we subtracted the travel times of the current scenario and the travel time of the simulated scenario of the no case. And the same way the delays we have estimated. So then the same way we can also estimate a fuel consumption respective to a distance traveled on the flyover and the distance traveled on the on road or maybe like at grade section. So on flyover at grade or like no flyover conditions are considered. The direction for the, okay, this is the flyover actual case. So for the 2 directions of the volumes as well as the delays, as well as the travel times and the fuel consumption as well as the emissions, everything we have taken on the 2 directional flow section. So then afterwards, then the travel time projected for the future case. So it is obvious that at certain point of the time when you are projecting a volumes, so from the 20 like the 2023 to 2025, then afterwards again every 5 years the volumes has increased, then obviously corresponding to the increased volumes, then there is a chances that increasing of the travel time, delays and everything that we have projected actually. So how the travel times, how the delays and how the fuel consumption are going to change respective to increasing of the volume. The same scenario we have there in the IRCSP 30 also. That's what we have already discussed from using of those equations. So these are the kind of the volume counts we have done for the on the flyover at grade and on the each direction of the flyover, on each direction of the flyover as well as the at grade even. So then finally what we have done, we started estimations of the, okay, we collected the travel time, delays and the fuel savings and all. So then we have estimated the travel time cost. Let's understand that how we have estimated the travel time cost. There is a kind of simple formula we have in the IRCSP 30. So if you open the IRCSP 30, what I have shared the kind of manual with you. So there is a very simple formula. So this formula is indicating that we have the total travel time cost. So this travel time cost, they have defined that. So it can be as the sigma of the total travel time on the stretch of the roads, or maybe like the section what we have selected, corresponding to the which factor to be multiplied. Somebody can guess, or like somebody can tell that. We are already discussed some example also. And corresponding to that vehicle category respective to the occupancy of the vehicles and how many number of such vehicles we have. That is the n value. So this is the formula we have. Travel time estimation cost. Any guess what is the factor here? Which factor might be impacting your saving of the travel times? It is there here actually. You don't need to worry too much. Vehicle operating time. So then if you have the, the value of the time. So the value of the time respective to the vehicle operation cost and all. So then that is the reason the I value is indicating that. The I is indicating that for the different categories of the mode, we have to estimate the value of the corresponding to the mode. So like the car, we have the different value of the time. Then the heavy commercial vehicle, we have the different value of the time. Bus, bike, auto rickshaw, and the LCV. So then we started estimations for the 2019, then the 2023. Then we have started projecting for the up to all 2050 values. So now we have estimated the average traffic volumes per day are the no flyover case, at-grade case, on flyover case, both. So the no flyover scenario is always indicating that before construction of the flyover on the road itself. But after construction of the flyover, we have the flyover as well as we have the road also at grade section. So then we need to estimate that no flyover case, what is the total travel time in seconds, and at grade case, what is the total travel time in seconds. So then on flyover, what is the travel time in seconds. So if you see that, so there is a kind of improvement, we can see significant improvements between the travel times between the no flyover case to the on flyover. So once you got the travel times of the different categories of the modes, we have done the car separately, heavy vehicles, or maybe like the commercial vehicles, LCVs, like auto rickshaw, bike. So each and every individual vehicles we have traveled at the different duration of the times and the different conditions. Then we have taken the average travel times actually. So you can see that 4 different methods we have adopted, and corresponding to the 4 different methods and the different conditions of the day and the different duration of the time in peak hours and non-peak hours, we have estimated, and those values we have averaged, and these average values are reported here. The same way we know already occupancy. So then what we have done, we multiplied that for each categories of the vehicle, the travel time into then the vehicle value of the time of corresponding respective vehicle into occupancy into number of vehicles. Then we will get the total travel time cost. So then this thing we projected up to the 2050. So then this is the amount in terms of the crores. So then if you add the total amount of the value of the at grade section plus on flyover minus of your no flyover case, then you will get that what is the total benefit from the travel time. If you see the beginning of the project at the only very less value like 1.86, but if the project goes on increasing, or sorry, the duration of the project has increased, so then there is a lot of savings on the travel time savings. So that means the travel time what we have estimated is converted into the cost or in terms of as benefit. Any questions? Hello?
Sir, this travel time cost we have considered by individual mode choice or
Yeah, it is there, na vehicle class, car, heavy
okay.
bus, bike, auto rickshaw, LCV. And corresponding to that, we have the occupancy also. Mostly if you see the car, we got the occupancy. This is the occupancy surveys also we have done. Mostly if you see on average, it is observed the 3 passengers. Then based on that, we have reported that we have taken at least a kind of 500 to 1000 samples of each category of the vehicle. Then what is the average occupancy we have estimated.
Okay, sir. Got it.
Any other questions from anyone? So that is the first benefits. Direct, we can see that actually, like yesterday, we have already seen the SP30 on the first day session. So then those are like the very, very direct benefits by saving of the travel time or vehicle operating cost, how it is improving the value of the time with respect to that, what is the total travel time savings as the benefit. So apart from that, we are also expecting there is a reduction of the delays actually. So like the reduction of the delays are also done for the no flyover. So then we have estimated what is the delay corresponding to the no flyover case. Then we have also estimated that corresponding to the edge grade as well as the on flyover, what is the actual delays. Because you can't say that, okay, there is a zero delay. So because it is expected that when the vehicle is traveling, so it is designed with respect to the design speed. So, okay, instead of discussing or like explain from my end, can you expect that why the delays will be expected? You have the road, then you have the divider case of the median, something is there, then you have the two lane on the either direction of the road. So somebody can expect why the delays will be occurs. As per our understanding, the delay should be zero, no? Because it is constructed a flyover actually. So like this is the kind of the road section. I'm asking whether the flyover, no flyover case, let us bother about, no, don't bother about it. But why the delays will be occurred on the road section?
The connecting road traffic will be merging at that point.
No, it's not like that actually. So just understand that actually you have the road. So this road we have designed respect to the maybe kind of specified traffic volumes. That's the reason we know the capacity of the road section. So if I'm taking a like the 2-lane divided roadway, so I know the capacity of the 2-lane divided roadway, maybe like the 4,000 vehicles per hour, something like that. I just example I'm telling, but it should not be like 4,000, maybe 2,600 to the 3,200 something. So most of the time, what happens at the different scenario of the traffic? So we have designed a section respective to the design speed of the 2-lane, 4-lane divided roadway. I'm taking for the example point of view, maybe like 80 kmph, but in the urban area, it may be like 60 kmph, something like that. So it is expected that every vehicle will move the 60 kmph. It is not at all possible because there is a truck. So if you are traveling behind the truck, even if you have the bike, so you should travel either with the speed, same speed of this truck, or maybe sometimes less than that speed. Or if you have the car, so if you have the car who is driven by the like the elderly people, and if you are traveling behind of that car, you will be traveled with the low speed compared to the actually what you are expected to travel like 60 km. So it is expecting that, or maybe like sometimes you have the so many vehicles on the road section. So adding of the any other one vehicle on this section, that may be reducing of your travel speed actually. So it is expected that, so there is a chances that you have the speed volume relation if you are taking. So this is the kind of the speed, and these are the volumes. So then adding at some point of the time, so there is increasing of the volumes, there is a kind of the achieving of the some specified speeds. So if you have the zero volumes, then you have the highest speed, then you adding of the volumes continuously, so then it is decreasing of the speed. At some point of the time you don't have any flow, so then obviously it is the completely jammed case. Okay, so that is the way. So even though you have flyover, there are different scenarios can be expected, either due to the additional vehicles on the road section, or else there is a kind of road user behavior in terms of the adding of the different drivers on the network that may be expected to reducing of the speeds, or else there is a kind of composition of the vehicles that is also expecting the reduction of the speeds. Then put together, there is a delay can be expected because all the vehicles are not traveling with the speeds what we are expected to travel as a 60 kmph. I hope you got the point now, why we have done the delay estimation sieving.
Yes, sir.
So when we are explaining to the commissioner, actually, he has pointed that, so why you are expecting the delay will be saved actually, because you are also talking about the travel time savings, which is directly it is talking about your delay, but it's not true actually. We need to have some idea as the transportation planners. So then we need to able to understand it actually, how the scenario will get changes, how the travel time will be need to see differently with the delays. So then the same no flyover case to the at grade or no fly on flyover case, we have done the same way the delays are estimated for the using of the different approaches. So then different conditions, then we have traveled the different speeds. So basically we know the actual speed of the vehicles at the different scenarios and what is the design speeds of the vehicles, then corresponding to that what is the expected travel time by knowing of the distance on flyover, because we know the starting point of the flyover and ending point of the flyover. At the same time at grade also we know starting point, ending point. Then when you're traveling a different speeds, like let us assume that if you travel a 60 kmph, that might be your actual travel time. So then you are expecting zero delay. Okay, there is no delay when you travel with respect to the 60 kmph, but my condition is different because I'm traveling during the peak hours, non-peak hours, different conditions with respect to the different scenarios of the different composition of the vehicles. Then obviously the speed will be like sometimes 50, sometimes 45, sometimes maybe like 65 even when you travel at the 6 o'clock morning, like that. So then all the cases we have done, then finally we have taken the average delays on the section. Then we have the occupancy, then we have the per capita income. So then we have the formula for the delay estimation or delay saved estimation, the same scenario like what we have for the travel time estimation. So it is also like the occupancy into per capita income, so into the what is the average traffic volume corresponding to the, because what we are expecting, if you are taking a average traffic volume of the 8 hours period, so those many number of vehicles might have saved their delays actually. So that's the reason average traffic volume for the 8 hours duration we have taken. So then corresponding to that, what is the actual delay saved, you multiply, then you will get the total delay saved cost. Then the same thing we have done for the 2019 to 23, we have prolonged it. So this is the kind of delay saved cost is estimated. But if you see that the delay saved cost estimation have significant difference with respect to the travel time estimation cost. So then what we have done actually, okay, let us assume that, so we have the scenario like, or maybe like what you call not scenario. So you have the actual fuel consumed for a 1 kilometer stretch of this road with respect to the when you're traveling a 60 kmph something, that we have the standard formula to estimate that even actually. So when you're traveling with respect to the 60 kilometers per hour, okay, so corresponding to the 60 kilometers per hour speed. So when you are traveling from the 0 kilometer to the 1 kilometer, so then we can expect that what is the average fuel consumed actually per 1 kilometer, what is the fuel consumed. So we can also expect this value can be indirectly we can estimate. Generally we will ask that now what is the mileage of a vehicle. Am I correct?
Yes, sir.
So if you know that each categories of the vehicles and what is the mileage corresponding to the fuel they might have used, maybe like petrol, sometimes the diesel cars, maybe like the auto rickshaw always, maybe they mostly like sometimes there are, we have also CNG and the electrical vehicles, those category of the vehicles are not included. So we have taken some percentage segregated in that actually. So that also done, we have done the indirect way of estimation. But if you have the different fuels, then the total fuel saved for the petrol versus the diesel, both we have taken separately, because the diesel cost is different and the petrol cost is different. When you're converting into the cost, those fuels are like those energy has to be segregated. So then how we are estimating this value, we know what is the amount of the fuel saved per vehicle, because we have the individual vehicles category like car, HCV, bus, bike, auto rickshaw, like that. So then when you are doing this process of the petrol or like fuel saved process, we have taken several vehicles as the kind of samples. Then corresponding to that, what is the average vehicles as using as the petrol as well as the diesel. And also we have cross-checked this data with respect to the registered number of vehicles in the city like Hyderabad, as well as we also taken some data or information from the petrol bunks or like the petrol stations. So this is the way this data is collected. Then finally what we have done, total fuel saved we have estimated. Then corresponding to this fuel saved estimated in multiplied with respect to the cost of the fuel, then you will get that what is the total amount cost is saved per day. Then it is again converted for the year into multiply with the 360. Of course, there is a kind of problem, or maybe I can say like kind of assumption we have. So there is no guarantee that. So there is no change of the delay. There is only improvement of the speeds over the time. When you are starting of the scenario 2019 to the 2035 or 40, up to some period of the time, so you might be enjoying the service like the flyover what you have constructed, but beyond that, so there is additional vehicles are attracting to that flyover. Then there is a, instead of increasing of the speeds, there is a decreasing of the speeds, then there is a more and more delay. So that means it is expected sometimes, so these delays saved as well as the fuel saved might not be true after certain period of the time, but as what we have projected, according to that, these values are still in the positive side. So then total cumulative savings are estimated at grade section as well as the unflyover section. And we have done the complete what is the total saving at grade plus unflyover together. So this is the total fuel saved cost estimated. So then what actually the thought process we have done. So okay, because this much amount of the fuel has saved instead of burned, then what is the amount of the emissions can be emitted if this fuel has burned? Because that is indirectly that amount of the emissions is also saved because it is not burned actually. So then what we have done, so okay, per 1 liter petrol or diesel consumption, what are the different types of the pollutants can be expected to generate? Then we have some formulas. So these formulas related to the emission factor estimation point of view. So then we have done that corresponding to the emission factors estimation process. Then we have taken that per 1 liter consumed of the petrol, what are the different types of the pollutants can be expected to be generated. So then, okay, we have the CO2, then we have CO, then we have the NO2, then we have the SO2, like these are the pollutants are identified. Then these pollutants, we have the process that how these pollutants can be damaging the environment and how these pollutants can be converted into the savings as the cost benefit. So that also we have. So that is there even the different economic impact evaluations point of view. Sorry, environmental economic impact analysis point of view. So then we have done the same way. So corresponding to the each saving of the fuel. So then we have started the estimations of the fuels consumed, fuel consumed or fuel saved we have estimated. Then corresponding to that, we have also estimated that what is the total amount of the cost saved corresponding to the fuel. So there is a kind of method we have. So this method we generally call as the, okay, if you have the average CO2, so then average CO and the average NO2 and all, so then we add together all the values. So then the cost of the pollutants by different what you call the Niti Aayog or like the different CPCB, yeah, Central Pollution Control Boards, they are releasing that there is a cost like per kg of the pollutant, because all the pollutants together we converted into the kgs. Then again we converted it for the year as the tons of the pollutants saved. So then there is a kind of a report they generated as 7.22 rupees per kg saving of the pollutants. So now we know that. So then this kg is to be converted into the tons. Then if you saving that much amount of the tons of the pollutants, so then what is the total amount of the cost saved respective to the pollutant? So that's the reason we have done here. Like I given the example respected to the petrol here. So like the total petrol saved we have done first. So the same way what we have done cumulative savings in the year. So then the corresponding to that CO2, COO2, NOx, NHMS we have taken. So then total emission saved cost per year. So that means if you put together all the values in terms of the kgs per day, then you multiply with respect to the 7.22, what is the number they have given CPCB side. So then you will get this emission saved cost or the benefit in terms of rupees per day. When this is converted into again year, then total emission saved cost is estimated. Okay, any questions till this point?
Sir, we have generally see that when a vehicle get old, it gets required more petrol or diesel, or it's generate a more emission. So in that case, we have consider means how can we consider that type of vehicles?
Yeah, very good point. Actually, it's very good point. The same thing we also thought of that. Okay, we have the registered vehicle system. Okay, let us assume that in the city we have the registration vehicle details. So what we have done actually, we have taken the at the different point of the time, what is the total number of registered vehicles are there in the city, and we have segregated that how many number of percentage of the vehicles are older than the 5 years, older than the 10 years, and older, if you more than 10 years or like 15 years old, obviously those vehicles emissions will be different than the 5-10 years old. So that we have segregated. Like if you have 1,000 vehicles, what is the percentage distributions of the age of the vehicles? So some studies they have shown that actually, so but there is no specific study there in respect to the Hyderabad. It is there for the Delhi actually. So CPCB they will publish that this is the kind of distribution, what you call the age distributions of the vehicle in a city. Okay. So in that we identified that okay, there is almost a 25% of the older vehicles are there in Hyderabad.
Okay, sir, got it.
But there are lot many studies, surveys has to be done for these kind of the works generally. So if you see that actually at the initial itself we have done so many surveys actually.
Yeah, it is applicable for the registered vehicle, but what about the freight or good vehicles? It is means it is travel from state to state.
Yeah, your
Or
point is correct, but if you see in the urban areas, mostly the heavy commercial vehicles, it is not permitted mostly during the daytime actually,
okay.
but only the night time is permitted. So the pollutant generated by the night time hardly, if you see even the total number of vehicles in the volume side, if I'm seeing, so it is very less actually. But still, those vehicles are also we have taken into the account.
No, actually, I want to matlab, I want to know means there will be any assumption we are taking about that part. Means
Uh,
I agree with your point. We did not get accurate data, but if there will be any assumption with the reference of any IRC or any reference
No,
paper.
there is no specific code at present. We have okay, these many number of vehicles are there as the different age categories, like old age, something like 5, 10, 15 years old. But we have taken data first actually, because if you find out the registered number of vehicle, from the registered number of vehicles, if you put in the Vahan site, then we can get to know what is the age of the vehicle, because we already collected the traffic volume, and corresponding to the traffic volume we have also knows the some different categories of the vehicles, their registered numbers are also. So from that we have estimated okay, in a day if I'm collecting a at least a 1 hour survey of the vehicles, what is the distribution of the age that we have done.
Okay, sir. Got it.
So anybody knows that if you put the your registered vehicle in one site is there actually, then it will give that the complete idea what is when it is registered, when it is purchased, and the what is the age of the vehicle, something. Even it will give the complete details of the vehicles also. Of course, there is another point actually I forgot to mention it. So there are different makes, and corresponding to the makes, sometimes if you see even if you are using as the petrol as the kind of fuel, but there are different types of the emissions actually which will be emitting from that vehicle will be different actually. Like if you see, like if I'm taking a like the Mahindra versus the some kind of other category of the vehicles, Tata. So then we have also tested with respect to the what you call gas tailpipe emissions, that is the gaseous emission estimation process. In that itself, we have identified that the total amount of the emissions emitted by the different makes will be different. All this information we have used when we are estimating the pollutants. So any questions or any points to be discussed? Okay. If no questions, then I will move on next slide. So that is the way we have estimated the total emission saved cost. Okay. So then we also done the accident saved cost. That is the number of persons are injured in 2015. So that is expected that there is no flyover case at the 2015. And the 2021, there is operation of the flyover is already in that case. Then the total number of accidents, like this is injured case and these are accidents case. So like there is a kind of differentiation with these numbers. The persons are injured, but the total number of accidents which may be including of the property damage alone, something like that. And the total number of fatal accidents. So you can see there is a fatal accidents completely zero in 2021, but still there is a 7 accidents are observed in the 2015. So this data we have taken from the police as well as the other sources from the, because we have GHMC has supplied that. Generally, apart from the police data, they will also collect the statistics. So they also supplied some of the information. So then we have done that corresponding to the medical cost value. So you know that actually, like somebody are very much interested about the crash cost estimation. So in that case, like we have the different time or different what you call the variables or like the factors to be identified, which are there. Okay, this cost generally, if you identify, there are the scenario like if the person is met the accident on a road, so then this person is completely sometimes is disabled in terms of their like severe fracture is happened. So then there is the disability of the person is happens. So happened. So because correspond to the disability, what happens? So then whatever the earning of this person is there, like maybe 30,000 per month. So instead of now this person is not earning even, but his person is depending on the others. So that means this person, whatever actually in terms of the medicine or in terms of the other activities to be done by this person, so he can't do its own actually. So that's the reason. So he's making more amount might be consuming actually. And also apart from this 30,000 who is expected to earn, instead of that is going to consume the medicine, is going to consume the different services from the others, that all to be converted into the cost. And there are a lot of assumptions are involved into that even actually. So that is the reason time spent by doctor or nurse of each patient that will be converted into the minutes, and this cost to be converted corresponding to the ways which is given for the doctor and the nurse case, and the average salaries of the doctor for the government hospitals, then the number of working hours and number of working days, and the cost incurred into the doctor and the cost incurred into the outpatients, and the average salaries of the nurse. There are different points they have taken into the case. Then for each one patient, what is the total amount of the expected cost that to be taken respective to their total cost expenditure for the outpatients or inpatients. Outpatient in the sense he is not admitted actually, but he is taking just medicine, he is consuming the service of the doctor as well as the nurse. And the inpatients he is admitted, so then there is a more amount of the service is consumed by that person. And the average stay in the hospital, that also to be taken. So then, so corresponding to that, percentage of the patients dies. So we have some kind of assumption again here actually. So like let us assume that, so you have the 7 members. So out of the 7 members, they died within the 50% died within the short period of the time. So like short period in the sense maybe within 3 months or 2 months, something like that. And the 20% of the people died at the after 6 months or 8 months, something like that means. So there is a way to understand actually. I hope if you people understood the process in behind of that, it is very complicated thing. It's not that easy. Like if you have the see the statistics showing that, so there are 7 patients are died. Okay, this is the meaning of the 7 patients. So now what I'm talking actually, these 7 patients are died at the different period of the time of the year. So I have the 12 months. So these 12 months, so if I'm looking that, so there are 4 members are died at the 6 months. Okay, or maybe like the 3 months, that is up to you, what are the assumption you want to make. So which means that these 4 persons consumed the different types of the services of their own house people as well as the hospital, like the doctor and the nurse. So the cost will be varies corresponding to that, what is the life or maybe what you call the kind of patient's survival case. the survival of the patient up to the some months in a year actually. Okay, so that to be estimated and to be converted into the cost, and corresponding to that, so then the remaining patients have the remaining survival time, maybe like the instead of 6 months, now some people might be survived 9 months, some people survived maybe 12 months or like 11 months. So out of all these accidents, we are expecting that, okay, there are some accidents are injured. So then these injured people only consuming the service, and there are remaining accidents are only property damage. So there is a loss of the property, but some people are died. So these are the cases we have. So then if you have the property damage alone, so then number of pedestrians or cyclists involved into that. So then the data is shown like only 3 people. Okay. So then the 2021 0 people, number of vehicles are damaged. So these are the kind of average number of vehicles are damaged, and the total number of insurance claimed. So this data will be mostly will be getting by the insurance what you call insurance sites or like the websites. They generally publish that this is the average insurance claimed by the people. Average insurance claimed by the vehicles. So then the vehicle to vehicle damages, like this data 100% or like the mostly 90% of the data we have taken from the secondary sources. All this information we generally get from the only secondary sources. There is no specific information published related to the damaged property damage case, or maybe like the medical cost, something like that. So then all together, so we need to find out that what is the total accident cost from the 2015 to 2021. Then we got that 15.80 is the total cost saved, because you have the look at the survival case of the people. So then 2021 there is no fatal accident first of all, and there are number of accidents has been reduced. So then finally we got the 15.8 crores. Yeah, any questions till this point? I hope somebody are there in online.
Yes, sir.
Any questions? Okay. So then, so what we have done, so what are the travel time saved and the delay saved, fuel saved, then the emission saved, finally we have the accident saved. Then put together, we have converted into the cost, travel time cost, delay cost, and the fuel saved cost, or like the emissions cost and the accident cost. So then this cost is the actually as the benefit in terms of the rupees actually. So that total benefits are estimated from the 2019 to 2050. So now we have done the details of the flyovers are also given by the agency, like what is the length of the flyover and what is the length of the road, construction cost, as well as the cost of the, so okay, length of the road before construction of the flyover, and the cost of the construction of the flyover, that is 45.1 crores, which is construction of the maybe like almost a kind of 2.2 kilometer. Then the open to the traffic, these details as given. So now with that details, we started the economic evaluations of the project. So then we have the 45.1, that is your cost of construction. Then we have added the routine maintenance, periodic maintenance. Then we got the total cost. Then we know the total benefits, but initially we have taken the total benefits of the respective value of the travel time, travel delay, like that. Then we have also taken that all the total benefits respective to the all the components together even. So we have done both the way. Then we got the NPV value. So of course we have done the different methods. NPV we have done, BYC we have done, IR method we have done. Yeah, 4 methods we have adopted actually. All the 4 methods we got that very good result actually. So like this is the earlier what we have shown, that is a 17.68 is related to the only travel time saved cost, 17.68. But if you add 17.68 plus 36.56 plus 22.56 plus emission cost 3.51 plus your road accident cost. But the road accident cost we have taken up to the initial base period to initial periods only. Remaining periods we have not taken because we can't expect any kind of accidents will be reduced, keep on reduced. So then we have taken the total benefits also. So then this is the total benefits up to 2050. When the cash flows we have estimated, then the discounted interest rate, then we have estimated the total NPV value. So now if you see the NPV value with alone travel time cost 128.69, then if I'm including all together, then it is 717.5. So then obviously this project is worthwhile to invest. So can you expect that why we have done the travel time separately with respect to all other benefits separately? So that is all about the presentation. So we are going to demonstrate one more aspect what we have done recently. So can you expect that what is the reason behind that, why we have separated the travel time and the what you call other costs or benefits? No idea, or no questions, or no comments?
Sir, as you mentioned earlier that we know before construction what happening and after construction what happening. That
Yeah, exactly.
great. That
Because that is we can see directly. Okay, we can understand. Okay, this is the direct visible or maybe like kind of monetary terms going to be happen after construction. The delay or maybe like the emission saved or maybe like the kind of the fuel consumed. These are like the kind of imaginary terms what we are expected to happening over the time. We don't know after certain period of the time. In specifically when we are doing a simulation, it is identified that beyond 2040 or 2045 onwards, there is no kind of improvement we have identified it actually. So then, okay, it is better to segregate a travel time alone than all other together separately. Yeah, good. That is the reason actually. Okay, if you don't have any questions, so then I will stop here from my side. So then my PG student like the Rohit is here. Rohit is going to demonstrate what we have done another project recently that is also in Hyderabad.
Yes, sir. Good afternoon, sir.
Yeah, good afternoon, Rohit. So are you ready now?
Yes, sir. I'm ready. Sir, can I know my screen is visible or not?
Yes, it is visible, Rohit.
Yeah, thank you, sir.
Yeah, I'm going to share this PPT also shortly. Today's PPT once I received from the Vinayak sir, I will share both the PPTs and what the PPT currently Rohit is also presenting, that also will share.
thank you, sir.
So yes, good afternoon to everyone. So now my name is Rohit Sagar. So and I am going to discuss about traffic growth rate and traffic rate estimation on Indian roads. So as we know, tolls are collected at toll plazas only at national highways, expressways, and some of ring roads. So there are there are the toll rate collection is of two types, like flat toll rate collection and distance-based toll rate collection. So in this PPT, we are going to discuss about distance-based toll rate collection. So the contents of this topic is our traffic growth rate estimation. So in this, we are going to discuss about how to establish base year traffic AADT and how to apply correction factors to it, and how to derive historical growth trend and estimate traffic elasticities, and how to project future growth rate of macroeconomic drivers and convert that macroeconomic drivers growth rate to traffic growth rate. So after that, we will going to discuss about toll rate estimation. So we'll have a brief intro on toll what is toll rate and how they are collected, and then we will move on to identify base toll rate and how to apply adjustments to it, and what is WPI, that is wholesale price index, and what is that escalation factor, and how to incorporate it in growth rate of the toll rate. And then at last we are going to discuss about estimate distance and OD matrix, and to estimate toll revenue up to future up to 2050 years future years. So first step in growth traffic growth rate estimation is to establish base year traffic, that is known as annual average daily traffic. So for this we need to conduct a survey of either 7 days or one day. If you are going to conduct a survey on one day, you need to find ADT, and based on that ADT and seasonal variation factors, we can find ADT. But based on one day's survey data, it's not accurate to calculate ADT. So what we prefer is to do a survey data for 7 days and to convert it into ADT, that is average daily traffic, and then use seasonal correction factors to convert it into annual average daily traffic. Then these annual average daily traffic need to be collected at both origin and destination of the corridor which you are going to select for the survey. And these data is not accurate, will not be accurate. So what you need to do is you need to check this with the secondary source data, like there will at the tolls there are cameras, so they will be recording each and every vehicle that is coming and going into the highways or ring roads. So with that data, we need to compare our data so that there is any variation. We need to apply correction factors to cover that variation. So let us see an example of how to apply correction factor to our ADT values. So this is an assumption values, not a survey that we have conducted. So let us assume that there are 20,000 vehicles per day, cars, and trucks as 5,000 vehicles per day. So total ADT is of 25,000 vehicles per day. This is just assumption. We will not do ADT like this. This is just an assumption. So then if we compare it with the secondary source data, that is toll cameras or all other data, so if we can see that the correction factor is 1.05. Here it denotes that there is a 5% change 5% change from our survey data, so which we get 1250 vehicles extra. So it is small number when we are computing according to ADT, but when we are forecasting it to the future years and calculating the toll rates, it will be estimating about some crores. So this correction factor is to be evaluated at the starting stage only, so that we at the end the toll rate estimation will be accurate. So after this, we will move on to how to derive historical growth trend and how to estimate traffic elasticities. So after estimating AADT, then that is we have estimated AADT to the base year, that is of from our example, that is of 2020. So we need to compare it with the macroeconomic variables such as NSDP, per capita income, population, and fuel consumption. These are the macroeconomic variables which influence traffic growth rate. So for comparing these macroeconomic variables to the traffic, we need to have 5 to 10 years of traffic data, that is past traffic data, because we can't have the NSDP PCA, that all that macroeconomic variables data of future years or the present year. So what we have to do is we need to calculate ADT data for we need to backcast our base year ADT data to before years, that is 2010 or 2015 from our base year to 2020. So what we have to do is we have to back calculate that ADT data by not assuming, but by taking some historical traffic growth trend, or by taking vehicle registration numbers of particular city or state. So by taking that growth rate, we can estimate the back calculated traffic at particular year, that is of 2015 or 2016, any year that we can estimate by using this formula. So then we need to compare it, compare it with NSDP, PCI, population, and fuel consumption. So before doing this, what we need to do is we need to collect the NSDP, PCI, and population data of particular states or districts where you are going to conduct the survey. That is, you are going to conduct survey on a highway or a ring road. That in that highway or ring road, there will be vehicles coming from other states also. So there will be zonal influence factor coming to account in this. That is, there will be traffic from other states also. So the GDP, NSDP, and PCA of other states will come into account for this zonal influence factor. So what we have to do here is we need to collect NSDP first let us take one macroeconomic driver, that is NSDP. So first we need to collect NSDP data for different years, for different zones, like different states. Then we need to find traffic. We need to find traffic vehicles that are coming onto the highway from different states, that we can get from video footage data if we take if we conduct a survey, or from toll cameras. So from that we will segregate the percentage of vehicles that is coming from every zone, so that we will have percentage of vehicles that is coming from different zones. So we will multiply that with the NSDP data. So we will get the weighted NSDP data of different zones. So with that data and with the traffic data that we have back calculated for before years, uh, with the both of the data we will run regressions, that is using log linear regression by also these will be done for different vehicle class, like for car these will be different, and for trucks this will be different, and for buses this will be different. So after doing regressions we will record elasticity, r square and t stat values from what we have done. So we will see a small example of how we go through this process. So after finding AADT of base year 2020, then we have assumed, this is an example, so we have assumed the base growth rate of 5% per year. So with this 5%, we have back calculated the traffic of year 2015 and 2010. And if we are doing the survey, and if we are calculating for any highways or any ring roads, we need to calculate for five years, that is 2015, 16, 17, 18, 19 and 20. Like that we need to calculate. And so here we have taken 5%. So for base year the vehicles we have estimated is 26,250. So for 2015 the vehicles that we have got is 20,500, and for 2010 it is 16,000 vehicles. So now we have traffic data from 2010 to 2020. So these traffic data should be matched with NSDP, and we need so after that, as we discussed before, NSDP should be weighted based on the zonal influence factor. So here we have assumed zonal influence factor. We have taken 3 zones. So for zone 1 is of 50%, zone 2 is of 30%, zone 3 is of 20% trips. That is number of vehicles that each zone is incorporating. So the ZIFs are 0 0.5, 0 0.3 and 0.2. So NSDP data that we have taken based on the 2020 data, that is of constant prices, is based on zone 1 it is 5,000, zone 2 it is 3,000, zone 3 is 2,000 crores. So if we are doing it practically for any highways, we need to collect not only for 2020 but also for 2019, 2018. So we can compare it with the AADT data, and we can do the regression model there. So after calculating, we will get that we'll get 3,800 crores as the NSDP weighted data after multiplying it with the general influence factor. So after that, what we do is regression. We will run regression, log linear regression, that is for traffic data, AADT data, and weighted NSDP data. So what we have to note is that elasticity parameter, that is beta here. So what this elasticity will tell us is that if you see here, cars elasticity is 1.2. So what does it define is that 1% increase in the economic variable, that is NHDP, will accommodate in 1.2% of increase in the traffic growth of cars, and for trucks it is 1.3. So if we observe here, for cars it is 1.2 and trucks it is 1.3. So by seeing this, we can say that the growth rate of trucks is more than cars based on NSDP, weighted NSDP. So then the next step is to project these macroeconomic drivers like NSDP. So if you, we want toll rate to be estimated for future years also. So we need to estimate traffic growth rate for future years. So for that, what we need to do is we need to estimate macroeconomic drivers like NSDP's future growth rate, and we need to convert that into traffic growth rate. So how we will get to know how to do it. So at first we need to link that NSDP. NSDP is net state domestic product, which is like a state GDP, and we need to link it with the national GDP. So here we can't link it directly here. We need to extract the data of NSDP data for NSDP data for different years, like we have extracted before, like 2020, 2019. So for forecasting the data, we can get national GDP data, that is growth rate data for future years, that will be given by RBI or RBI. So national GDP data. So we will link NSDP data with GDP data, and we will do regression analysis, regression like this, like log regression, like ln of NSDP equal to a plus b into ln of GDP. So by this, if we take b as the elasticity value, if we multiply b with the projected GDP rate, we will get the NSDP growth rate. So in this way, we will get the growth rate of NSDP for future years. So in this way, we need to estimate it up to the desired year that we want for our project work or anything, like 2050 or 2040, like future years. So if we take an example here, so what we got here is the projected GDP rate. If we assume it as 6.5%, while we have done regression, what we got elasticity was 0.95. So when we multiply those both, the NSDP growth rate will be 6.2%. So these should be also done for different vehicle classes. Like it should be different for car, it should be different for truck, and it should be different for buses. So individual vehicle class, it should be different. And before, we have taken cars elasticity, traffic elasticity as 1.2. So if we multiply the traffic elasticity with this NSDP growth rate, we will get the traffic growth rate of cars. So in this way, we will get the traffic growth rate for different vehicle class. Like for cars, it will be different per year, and for trucks, it will be different per year. These should be estimated up to the desired years that we want for our project work, like 2050 or 2040. So we'll have a stop here. If anyone has any doubts, I'm ready to answer.
Which project, sir, you have worked on this assignment?
Sir, we have worked for Hyderabad Outer Ring Road, sir. We have worked for Hyderabad.
Okay, Hyderabad.
Rohit,
Yes, sir.
you have used several formulas in your PPT.
Yes, sir.
Actually, what are the sources?
Sir, those
What?
what formulas I have used is of regression formulas, sir. So those are mathematical. There are no sources for this.
No, no, I understood. I think you used one formula. Actually, PPT number was not mentioned.
So, can you show me the source? I will show you.
This one, this one. Back, please.
This
Back,
one,
back.
huh?
No, no, no. Back up, back up. ADT. You just back. थोड़ा सा back आना. Yes. You have used one formula. Yes, yes. Yeah,
This one, sir.
project
Yes.
ADT. This one.
Yes, sir. This one here, I have told that for we have conducted survey data for base year, that is 2020. So we need to compare the macroeconomic variables like NSDP with traffic data AADT. So macroeconomic variables data we will not get for base year or the future years. We should extract the data for the past years. So we need to we need to calculate the past year's AADT data. So if we have the traffic data, it's good and fine. If not, we need to take historical vehicle resistance data or traffic growth rate data to estimate back calculated traffic data for respective years like 2019, 2018. So for that, we have used this formula, sir.
Okay, okay, understood.
So I have, okay. If no doubts, I will move on to next slide.
Yeah, please.
So next, after estimating traffic growth rate, then we need to find the toll rate estimate. Then we move on to toll rate estimation. So what is toll? Toll is a fee charged for road usage, typically based on distance travel. So this distance travel toll rate is new to our India. These will be taken on expressways and ring roads, not on every highway. They will be charging distance based toll rates. They will be charging like flat toll rates. So these rates differ by vehicle category. Like cars, there will be different tolls charged for different vehicle categories. Like cars will be have different toll charges, LCV will be have different toll charges, and trucks will be having different toll charges. So NHIA 2007 and 2008 gave base toll rate per kilometer, which we will be using to calculate the toll rates based on the distance that the vehicle are going to travel. So toll rates we need to calculate it for the future years, that is up to 2050 or 2040. So for that there should be improvement or decrement in the traffic growth rate that we have estimated before, and also there will be inflation for the toll rates, which we will be using wholesale price index to normalize that inflation of toll rates. So to know that toll rates, we need to refer National Highway Fee Rules 2008. So in that they have given the base toll rate for cars, that is 2023 and 2024 is 1.73 kilometers. That is for 4-lane highway, and these toll rate will be different based on the road structure also. So for higher multipliers for expressway and like for special structures. So for expressways it will be like 1.25 into base rate. This base rate will be changing every year. So the base rate that NHAI will be given is of 2011 and 2012. And it for the special structures like bridges and tunnels, it will be 1.5 into base rate. Next, what is WPI? The WPI is Wholesale Price Index, is an economic indicator that measures the average change in the price of goods at wholesale level, that is before they are sold to customers. So we use WPI here to counter the inflation rate of toll price that every year. So we are going to estimate for future years. So every year the toll rate should be either increasing or decreasing, which will be defined by the wholesale price index. So the formula for using calculating new rate of WPI is new rate equal to previous rate into 1 plus WPI increase per according to the year. The WPI index increment we can get it through Office of the Economic Advisor website. So WPI base year values is of 2011 and 2002, that is currently for India. Then we will see an example to how to calculate that increase in the toll rate with respect to the WPA. So if we take the WPA base equal to 100 based on 2011 and 2002, that is the source from NHIA. So current for the present year, the WPA is 154.1. So from this we will be estimating the base toll rate. So revised base toll rate equal to previous base rate into 1 plus 0.4 of WPA current minus WPA base by WPA base. So here 0.4 is that that NHI has given that toll rates increase by 3 to 5% every year. So we have taken 4%. These 3 to 5% you can find it in NHI 2008. So this revised toll rate formula will be 1.22 into 1 plus 0. Here 1.22 is previous base rate that we have assumed. So if we incorporate this WPA current and base here, we will get a 1.48 revised base toll rate. So previous base toll rate is 1.22 and revised base toll rate is 1.48. So there is an increase because there is an increase in the WPA current value. So toll rate is by this we can say that toll rate is directly depends on WPA values. So final base rate will be 1.48 into 1 plus 0. So here as per contract and WPA adjustment, we 3 to 5% we have taken 4%. So it is of 0.52, 4% of 1.52. So these are 13 years. So final base rate is 1.48 of 1 plus 0.52, which is 2.25. And the next step is, so here we have got the final base rate of toll rate that we are going to use to estimate toll rate based on distances that the vehicles are traveled. So that distance, what we need to do is we need to estimate the distance. So we need to construct an OD matrix, OD matrix for traffic that is going from origin to destination. So we need to calculate distance traveled by each vehicle types. Like that toll rate should be different for cars, as we have discussed before. It should be different for cars. It should be different for trucks. It should be different for heavy vehicles. So we need to construct a OD matrix for different origins and destinations. So for the project, what we have done for outer ring road, there are 21 exits and entry points. So we need to draw 21 exit and entry points, data entry and exit points, so that from each entry to exit point, we need to estimate the distance of how much that vehicle will travel. So so now we have the OD matrix of distance of distance from origin to destination, and we have base toll rate. So here in this table we can see that distance OD matrix. This is not our data. This is assumption data that we have they had taken for this session. So if we see here, this is from place A to B, the distance is 12 kilometers, and from place A to C, that is 21 kilometers. So as such, that the distance from B to A it's 12, B to C it's 9. So these are distance table, and toll for car, it should be estimate in the formula for estimating toll for car is distance into base rate per kilometer. Thus that base rate per kilometer that we have estimated before, and if we multiply that with the base rate, we will get as this 2746 like that. And if we multiply this with that, so to get total revenue for car, we need to multiply toll with respect to the traffic. So here we have taken total 7 days of traffic, but if we want AAD for year toll rate, we need to multiply it with AADT. So we will get toll rate per year. So if we have, so in traffic growth rate, we have estimated growth rate with for future years also, like up to 2040 and 2050. So if we estimate AADT for the future years with respect to traffic growth rates, if we multiply those with the toll for each vehicle class, we will get the total revenue for each vehicle class. When we add up all that toll for all the different classes of vehicles, we will get a total amount which is known as IECV values, initial estimation concession value, which will be estimated at the beginning of any project evaluation or something. So thank you. If any doubts, I'm ready to answer.
Sir, how we can calculate it, that growth rate means in this calculation?
Traffic growth rate.
Yeah.
So traffic growth rate. See, I will say it in short. Like to estimate traffic growth rate, first we need survey data. Survey data that is of 1 day or 7 days. So if we have survey data of 7 days, we need to convert it into ADT, that is average daily traffic, and then we need to convert it into AADT, that is average annual daily traffic. Then we need to apply correction factors by using secondary sources data. So we will get AADT for our base year, that is of 2020, or if you are taking the survey now 2025. So then we will back calculate this base year traffic data for before years like 2019, 2018, because we need to compare this with NHDP data. Like NHDP data, we won't get the data for future years or for the present year. They will be giving the data after the completion of the year. So we will have only the data that is of previous years. So we need to back calculate the traffic data of present what we have got to the we need to use back calculation to calculate for 2018 and 2019, that up to 5 to 10 years. So to calculate that, we need to assume a percentage, like not assume, we need to take percentage with respect to vehicle registration, or if you have traffic growth rate of previous years, it's well and good. So based on that, if we will get traffic of previous years and NHDPs, what we have to do is if after collecting those NHDPs, not if you are taking any highways or ring roads, the traffic that are roaming on the roads will not be only from one state, that will be from 5 6 states. So there comes the topic of zonal influence factor. So there will be 5 6 zones that are influencing the traffic on the highway. So what we need to do is we need to collect the data of an NSDP data for those 5 6 states, and we need to multiply it with zonal influence factor. How we will calculate zonal influence factor is, as I said, from video footage data, while conducting survey, if we take video footage data, so from that video footage data, from origin and destination, we need to see how many vehicle registration numbers, like from Andhra Pradesh or from the Telangana, from Madhya Pradesh, the different type of vehicle registration numbers. We need to collect those, and we need to make it into percentage of vehicles that are coming from different states. So by that we will get zonal influence factor, and if we multiply NSDP with zonal influence factor, we will get the weighted NSDPs. So with respect to weighted NSDP and with back calculated AADT values, while we do log linear regression for different vehicle classes, we will get elasticity values. So as I said, elasticity, it is important because if we observe here, car beat elasticity value is 1.2. So if we take 1% of increment in NSDP, then will be an increase of 1.2% in cars, growth rate of cars. So for this, these elasticity will prove that macroeconomic variables are connected to traffic growth rate. So we need to note this elasticity values, R square and T star values. Why we need to do only regression is that we will get R square and T star values, so we can see the significance of those like significance values, that is this NSDP really significant to our calculation or not. So then after calculating elasticity values, then we need to estimate future growth of macroeconomic variables. That is, we will take we have taken for different growth rate for different states. We need to compare it with the national GDP, and we need to forecast that NHDP for future years by using same log linear regression as we have done before. So when we multiply the projected GDP growth rate of India with the elasticity values that we have got from this log linear regression, we will get the future forecasted NHDP growth rates. So when we multiply this future forecasted NHDP growth rates with the elasticity that we found before, like we have calculated for car 1.2, so we will get the traffic growth rate. So if we calculate it, this is for the base year, that is 2020. So if we calculate for 2025, 2030, the growth percentage will be different.
Yes, sir, got your point. If possible, there will be any Excel sheet you have for
Yeah,
this all.
yes, we will share an Excel with data
Yeah,
of
yes.
growth rates and all that. You can use that growth rates and these formulas to estimate toll price. After
Yes,
this
sir.
session, we will share it.
Okay, sir. Okay. Thank you.
Thank you. Any more doubts?
No, sir.